Good morning, everyone. Welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So, guys, everybody in the chat box, am I visible? Am I audible to everyone? Am I visible? Am I audible? If yes, then write yes in the chat box so that we can start the class. Okay? Yes, everybody. Hanji. Everyone in the chat box, if I am visible and audible. Hello, Sneha, Tisya, Nixon, Jasmine, Disha, Philo, Sukanya, Divesh. Yes, hello students. So, in today's class, we are going to do chemical kinetics, right? So, let us start the session and happy Dhanteras to everyone. Radhe, 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 Radhe. Happy Dhanteras, everyone. Yes, audible. Perfect. Hello, Rathi, Bama, Philo. Okay. So now let us start the session where we are going to complete chemical kinetics. Today it's a very simple, very easy chapter, yet a very scoring chapter because you are easily going to get 2 to 3 questions from here. Right? Minimum you will get 2 to 3 questions from here. And it's not like complicated questions will be asked, very simple question because I am also going to take PYQs, right? So you will have an idea what kind of questions they will ask, very simple, direct formula based questions. Okay, yes, happy Dhanteras, happy Dhanteras. Okay, so now without wasting any time, let us start the session, Now basically what is chemical kinetics? If you talk about the term chemical kinetics. Okay, tell me what is kinetic energy? Kinetic energy is the energy of motion, right? When you're moving. So similarly, kinetics means when reaction is moving, right? So in this, like in kinematics, in physics, in kinematics, what you study? In kinematics, you study about speed, right? What is the speed, this and that, right? So here in chemical kinetics, you are going to study the speed, that is called the rate, right? And in chemistry, we have reactions, so that is why we are going to study rate of reactions, right? What is the rate of the reaction that we are going to study in detail, right? So for that, firstly, we need to understand rate of what kind of reactions we need to study. So if you divide the type of reactions into 3 parts, there are basically 3 kind of reactions. One is very slow, another is moderate, then it is fast reaction. If I talk about a very slow reaction, if you talk about rusting of iron, right, you have iron, what do you think? You have some iron board or iron anything, utensil, anything like that, iron jar, anything, right? Iron stick. Now, if you bought that iron stick, will it get rust within 1 day or within 1 hour or within 2 hours? No, right? It will take hours and hours. That means it will take years to have that rust on the iron, right? So that chemical reaction is a very slow reaction, right? So slow reaction, you can understand this by rusting of iron. Rusting of iron, which is a very, very slow process, very, very slow process. When we talk about fast reaction, what are the fast reactions? For example, when neutralization reaction, acid reacting with base, right? When acid reacts with base, instantly, like within seconds, within nanoseconds, right? You have the formation of salt and water. So basically, it's a very fast reaction, right? So example can be neutralization reaction, metal with an acid. These kind of reactions are very fast reactions, right? So you can understand this by this thing. For example, someone is already very intelligent, right? Very intelligent, already the topper of the class, right? What I can teach that person, right? He's already gaining 720 out of 720 NEET mock test. So what can I tell that person, right? Okay, he's already perfect. He or she is already perfect, right? So I don't need to tell them anything. If you talk about a person who is not only interested in studying, he's like, I don't want to study, I don't want to do anything. what I am, how come I will be beneficial to that person? Because that person don't want to study only. He's like happy in his own world that, okay, I don't want to study. I'm happy the way I am, right? I can't do anything. So similarly, you can't study slow reactions, very slow reaction. You can't study very fast reactions as well, right? What we study in chemical kinetics are the moderate reactions, right? We study the rates of the moderate reactions, right? Okay, so these are your, where we will study the chemical kinetics, we will study the rate of the moderate reactions. Is it? Rate of the moderate reactions we will study here, right? Okay, understood this part? Yes. Now, next is rate of reaction. Now, ma'am, we are talking about rate, but what exactly is the rate, right? Okay, what exactly is a rate? So, if you talk about rate of anything, right, I am writing rate of anything, that is always equals to change in that thing divided by time. That will be called as the rate. Right? For example, if I talk about rate of saran, what is rate of saran? Rate of saran is change in saran divided by time. What is the rate of litika? Likita. What is the rate of litika? Litika needs likita, है ना? So that is change in likita divided by time. Acha, what is rate of rati? Rati is change in rati divided by time. So if I want to talk about rate of reaction, that will also be change in which thing. Now tell me one thing, when there is one reaction occurring, which thing is changing in that? Hello, 𝐂𝐡𝐞𝐤 is here. Yes, Chintu ma'am, Dosa ma'am, yes. The rate of change of, because it's a physics thing only, right? It's a kinematics thing only. So rate of change of 𝐶𝐴 is equals to change in 𝐶𝐴 divided by time, right? Okay. So now rate of reaction is what? Rate of reaction is change in which thing? What we change in a reaction? Yes. Let us see 𝐶𝐴 will be able to answer this or not. Yes, what we change in a reaction, which thing is changing? Distance is changing. Are we talking about physics here? No, right? No physics here. We are talking about chemistry. A reaction is occurring here. So, which thing is changing? The concentrations are changing. The concentration of reactants are changing. Reactant is getting converted to product. There is formation of new product. So, that means here the change is in the concentrations of which thing? Concentration of reactant or product. The change in concentration of reactant or product divided by the time, because always with rate we have the time, right? Derivative of constant 0. Okay, sir is on another level only. Sir is like, okay, I'll say something that everyone will be like, okay, chemistry is still easy than physics, right? Okay, so now this is rate of reaction. Now, for example, I talk about a reaction. This is the reactants. This is changing to products, right? Now, this rate of reaction, I'll represent this by ROR, okay? So, this can be this ROR, ROR means rate of reaction, okay? Instead of writing that again and again, I'm simply writing rate of ROR. So, ROR can be written in two forms, right? In two forms. One is your change in reactants, other is change in products, right? One is change in reactant, other is change in product. So, I'm writing here that initially it was Ri and final it is Rf. Initially it was Pi, final it is Pf, right? Now, I want to write the rate of that reaction here. What will be the rate of that reaction? ROR equals to, that is the change in reactants. What is the change in reactants? Final minus initial, right? Simple. So, Rf minus Ri. Right now, I am not talking about any sign convention, okay? We are not talking about any sign convention. Time, I am representing that this is your Ti and this is your Tf. This is your final time, that is your initial time. So divided by the change in time, right? That is your Tf minus Ti, right? And if I want to write it in the terms of products, it will be Pf minus Pi divided by Tf minus Ti. Is it? Now understand one thing. There is a property of rate that rate can never be positive. I am writing it here. Rate can never be positive. Sorry, rate is always positive. Rate is always positive. Always positive. Rate can never ever be negative quantity. It is always a positive quantity, right? The rate is always, speed is always positive. We can't say my speed is minus 10, right? Okay, that is in the opposite direction, right? That we will see in physics, right? But in chemistry, rate can never be a negative quantity. It is always a positive quantity, right? Okay, so rate is always positive quantity. Now tell me one thing. If I apply this thing here, rate of, this is your final reactant minus initial reactant. Now concentration of reactant is decreasing or increasing. Rate of concentration, integration of Kapto is equals to Champa, derivation of Kapto is equals to Pandu. Okay. So now here you have final reactant minus initial reactant. So tell me one thing. Will if something is reacting, right, the reactants will decrease their concentration or increase their concentration? What will happen in this case? Reactants is going to decrease the concentration, because reactants are getting consumed. If you are eating something, right, if you are eating your food, then what will happen? The food will increase in the plate. No, right? If you are eating something, the food will decrease in the plate. The food will increase in the stomach. In the plate, it will decrease. So if you are eating something, it is going to decrease, right? The reactants are going to decrease, right? So the concentration, we know that Ri is less than, Ri is greater than Rf. Then Rf minus Ri will be negative. Then this term will be negative here, right? This term will be negative here, right? And time is always increasing because time is always increasing. No, time is never decreasing, right? So this is increasing only. So that is why here this is also going to be positive. That means the overall rate is going to be negative. Do you agree with that? This overall rate will be negative. But I told you that rate can never be negative. Rate should be positive, right? So what they did, they said that do one thing. You should have a minus over here. Only then you can get your rate as positive in this quantity. That is why whenever we are writing rate in the form of reactants, very, very, very important line. Whenever we are writing rate in the form of reactants, there should be a minus sign in front of that. If you are writing rate in the form of products, there is no need of writing the negative sign over there, right? Okay, this is a very, very important thing, right? Now, that was the first thing. Now, let us see the second thing, that is, the second important thing is rate is defined for 1 mole. Rate is defined for just 1 mole. So for example, I have a reactant, I have one thing that I have, this is the line, right? For example, you don't have 1 mole, instead you have so many moles, that is R of R give rise to P of P. That means R moles of reactant R and P moles of reactant P you have, right? Now, what we were supposed to write? We were supposed to write rate in the form of, reactants, right? Okay, one more thing here that you can write here, that there are basically two types of rates. The same thing that Kapto was talking about, right? So one is your average rate. Chemistry is also tough, little bit. Average rate, right? Chemistry will always like, okay, I want to look cool, so I will also have differentiation, integration somewhere to scare the students, but actually it is easy, right? You will just get scared of that thing. Oh my God, ma'am, differentiation. Oh my God, ma'am, integration, ma'am, what to do, ma'am, what to do. But in reality, only those 3-4 formulas you will use for differentiation, integration everywhere. The formula of log you will use everywhere, right? So one is your average rate, other is your instantaneous rate. You know what is average rate? Average rate is when we talk about a large time interval, right? When the time interval is large time interval. Okay, what is this instantaneous rate? When we talk about small time interval. When the time interval is very small. Now, see one thing here, when the time interval is very large and small. I told you this in thermodynamics as well, that whenever, throughout physics, throughout chemistry, you have to remember one thing, that whenever there is large chain, that is represented by this triangle, that is called delta, right? When there is small change, that is represented by this D, right? When there is small change in steps, right? So here it will be called as, here rate of reaction will be, that is minus of delta R by delta T, and in product side it will be delta P by delta T. What is delta? That is change, right? Because here we are writing in the form of change. No, this is change, this is change, this is change, this is change. So change, if it is very large, then it is represented by average rate. If the change is small, then we will represent it by instantaneous rate, that is by minus dr by dt, or this is plus dp by dt. Just remember one thing, that for reactants there is one minus, for product there is no minus, there is positive, right? Okay, so that we can make the overall rate as a positive quantity, right? Okay, so that we can make overall rate as a positive quantity. Yes, students, very good, very good, very good. Now, let us see the rate of reaction here. Very, very important. Now, I was telling you about that rate of reaction is defined for just 1 mole. Now, when you don't have any stoichiometry, you don't have any moles there in the reaction, just like this, then to take a chill pill, like no tension at all. But they will not give you that kind of reaction, rather they will give you this kind of reaction, right? So always remember what will happen to define it for 1 mole. If I am writing it very easily, what I will write, rate of reaction is equals to, if you talk about the reactant side, it will be dr. And I will be writing the instantaneous and both averages. So let us write both average and instantaneous rate. So this will be delta R by delta T, and this will be positive of delta P by delta T, right? In terms of instantaneous, this will be minus dr by dt, and this will be plus dr by dt, right? Now, one very important thing I told you, that the rate is defined for 1 mole. Here I am not defining the rate for 1 mole. To define it for 1 mole, I will have to divide it by the stoichiometry, right? So here the stoichiometry is R. So I will divide it by 1 by R. Here the stoichiometry is P. So I will divide it by 1 by P. Here the stoichiometry is for reactant, it is R. For product, it is P, right? So that will give your final answer, that rate is defined for 1 mole. This is the rate of that reaction. Here I am not talking about rate of appearance, rate of disappearance. No, right? Rate of appearance. If you are taking, okay, tell me which thing is disappearing. Which thing is disappearing? Reactant is getting disappeared, that is getting consumed. So rate of disappearance of capital R, or you can say rate of appearance of product, right? Now this rate of appearance and disappearance is not defined for 1 mole, right? That is not defined for 1 mole. Rate of that reaction is defined for 1 mole. right? Rate of reaction is defined for 1 mole, but rate of appearance and disappearance is not defined for 1 mole. So we will simply write it as, it will be for reactant, it is minus dr by dt, or it is minus delta r by delta t, depending upon the question, right? Usually you will use small only, that is you will use dr by dt only, right? Then rate of appearance is positive because we are talking about products. This is dp by dt or plus delta p by delta t. Okay, that will become your answer. Is it correct, everybody? Very good, Sneha, very good, Nicola, Madhumati, very good. DP where? Oh, यहाँ पे, yes, it should be DP, yes, so sorry, yeah, so it will be DP, right? Okay, so DP, yes, okay, so just remember one thing, that for rate of reaction, you will divide it by the moles, but for rate of appearance and disappearance, you will not divide it by moles. So I'll give you one simple reaction here, that is you have NH3, you have N2 plus H2 give rise to NH3. Firstly, you need to balance this equation, that will be 3 and this will be 2, right? Now, firstly, I am asking you, write the instantaneous. In the instantaneous form only you write this, right? So, everybody firstly write the rate of reaction, right? If you write the rate of reaction, that will be defined by, that will be for reactants dN2 by dt, because there is one stoichiometry. This will be minus 1 by 3 dH2 by dt, because here the stoichiometry is 3, so it will be 1 by 3, right? And here we are talking about reactants, so there is 1 minus. But when we talk about the products, it will be positive, right? This will be dNH3 by dt, but as we are talking about rate of reaction, so in that case we will divide it by the stoichiometry, right? So it will be 1 by 2. That will become the rate of that reaction, right? But when we talk about the rate of appearance and disappearance, right? If we talk about rate of appearance of NH3, rate of disappearance of N2, rate of disappearance of H2. So here you have three things: rate of appearance of NH3, rate of disappearance of this, right? So as I told you, rate of appearance of disappearance will not be divided by the moles. So it will be simple. Rate of appearance of NH3 will be, this is product side, so it will be positive of d NH3 by dt. Here it will be disappearance, it will be negative. This will be dN2 divided by dt, right? Here also it is disappearance, so it will be minus of d. This is H2, for reactant we are writing minus, and this will be your answer. This is rate of reaction, this is rate of appearance, disappearance, right? Okay, understood this thing? How many of you are getting any problem in writing the rate of reaction or in writing rate of appearance and disappearance? Is there any problem in writing the rate of reaction and rate of appearance and disappearance of the reactants and the product side? Yes? Very good, Sneha. Very good, Shabash. So now, next thing is, we want to have a relation between rate of reaction and rate of appearance and disappearance. So, see one thing, rate of reaction is equals to minus of this thing, right? So, wait a minute, I'll just make a relation here itself, right? Okay, here only we will make a relation here, right? Let us see. Okay, so if you put this value in this value, so rate of disappearance of N2 is equals to rate of reaction. So can you write rate of disappearance of N2 is equals to rate of reaction? This also they can ask you, right? Okay, if you talk about H2, then if you put this full value over here, this is your rate of disappearance of H2, right? So can you say that rate of reaction is equals to rate of disappearance rate of disappearance of H2 divided by 3, right? To make it more easy, can you write rate of disappearance, wait a minute, rate of disappearance will be equals to rate of reaction multiplied by 3. Because you will take the 3 over here, 3 into rate of reaction is equals to rate of disappearance, right? If you talk about this thing here, this is your rate of appearance of NH3, right? So can you write 2 multiplied by this rate of reaction, rate of appearance of NH3 is equals to rate of reaction into 2, right? Rate of reaction into 2. That will become your relationship. Now, ma'am, should we write all the things and then define the relation between rate of reaction and rate of appearance, disappearance? No. You can directly see that rate of appearance or disappearance is equals to rate of reaction multiplied by stoichiometry coefficient. For example, for H2, stoichiometry is 3, so it is multiplied by 3. Here the stoichiometry is 2, so it is multiplied by 2. So for general, we can write, generally you can write rate of appearance or disappearance, whatever you are talking about. Rate of appearance or disappearance is equals to rate of reaction multiplied by stoichiometry multiplied by, this is a very useful relation, very useful relation, right? So rate of appearance or disappearance is equals to rate of reaction multiplied by stoichiometry. Okay, shall we do one question based on this? Everybody in the chat box, I'll give you one question, very simple, right? Let us see if you can apply these things or not, right? Okay, with this question you will be able to understand all the things here, right? So the question says that you have, randomly I am writing, for example, let us talk about SO2 plus O2 give rise to SO3. So this is your 2, this is also 2, right? So now here I am saying earlier it was 100 molarity, now it is 20 molar, right? Earlier the time was 0 seconds and now the time is 40 seconds, right? Now the time is 40 seconds. Now tell me what will be the answer of, you have to find the rate of reaction, rate of appearance of SO2, SO3, rate of disappearance of SO2, rate of disappearance of O2, right? Everything you have to find from here, everything, all the things you need to find from here itself, right? So best way to do this is find the rate of reaction firstly, right? So firstly what we will do, firstly we will find the rate of the reaction. So rate of reaction, right, will be equals to, it is equals to minus of 1 by 2 delta SO2 by delta T. What is SO2? What is the change in SO2? This is minus 1 by 2 and this will be 20 minus 100 divided by time is 40 minus 0. So it will be minus, this will be minus 80 plus 80 divided by 80. So it is going to be 1, right? Rate of reaction will turn out to be 1, right? Now once you have rate of reaction, you can calculate anything. Rate of appearance of, or okay, you can say rate of disappearance of SO2, rate of disappearance of O2, directly use that general formula. Rate of appearance of SO3. Directly use that formula, students, directly use that formula. Let me see how many of you can answer this. How many of you can answer this? Hanji, how many of you can answer this? Rate of appearance of, rate of disappearance of SO2. What was the answer? Stoichiometry, that is 2, multiplied by rate of reaction, that is 1. So answer is 2. Here it is disappearance of O2. Stoichiometry is 1 multiplied by 1, answer is 1. Here the stoichiometry is again 2 multiplied by rate of reaction, answer is 2. So this way, from one single thing you can calculate rate of reaction, disappearance, appearance, everything you can calculate from that, whatever they ask you in the exam. Okay? Okay everyone? Is that clear to everyone here? Is that clear? Is that clear to everyone? In the chat box, if that is clear or not, only then I will proceed. Right? Okay? Otherwise, I will also sit silently here. Right? You need to interact, only then I can teach. Otherwise, it's not in my hands to teach. Right? Otherwise, I'll be just standing like a statue here. Okay? Yes. Rate of disappearance of O2 is 1, appearance of SO3 is 2. Okay? Yes? Okay, perfect, perfect. Now, let us see other things. To me, it feels like you guys are not only interested in studying. Yes? 4 marks confirmed. That is true, because that is a very, very important question, right? That they ask you. This to beta we have already done, right? So, I'll just delete this thing here, right? Okay. Okay. Now, let us do some questions based on this. First is your NEET 2019 question, that is, the same reaction is given to you. They are asking you the correct option, right? The correct option. You just write the rate of reaction here. Rate of reaction is equals to minus dN2 by dt equals to minus 1 by 3 dH2 by dt plus 1 by 2 dNH3 by dt. Right? Okay. Very good. Very good. Very good. Now, here, what will happen? You have to make a relation between H2 and NH3. Right? Firstly, let us see the relation between H2 and NH3. H2 and NH3, the answer will be, here it will be, this cannot be the answer because both are negative. So, this cannot be the answer. Here, one is both are positive. Again, this cannot be the answer. Here, one is negative, one is positive. But here it is 1 by 3, here it is 1 by 2. So, this also cannot be the answer. So, let us see between N2 and NH3. Between N2 and NH3, it is the correct answer because N2 is minus dN2 by dt and NH3 is plus 1 by 2 dNH3 by dt. So, answer D is the correct answer. Right? D for Diksha ma'am is the correct answer. Okay? Yes. You need to see the signs also here, okay? The one who has answered B, you need to see the signs also, right? Okay, be careful about that, right? Okay, chalo. Now, next is factors affecting rate of reaction. Factors affecting rate of reaction, there are so many factors. First is your nature of reactants and products. Reactants, are they very willing to take part in the reaction, or reactants are not willing to take part in the reaction? What is the stability of the product? If product is very stable, the reaction will occur on a fast rate, right? Second is the surface area. More is the surface area, more will be the surface for the reaction to take place, right? That is why more surface area, it will increase the rate of reaction. Third is concentration of reactant. If the concentration of reactant is very high, right, then definitely, for example, we all are fighting for something, right? We are in a big amount, right? We are thousands and thousands of people who are fighting for one thing. Then definitely there will be some kind of justice for you, right? So that is concentration of reactant is very high, right? That means definitely the reaction is going to occur in this case, right? Catalyst will affect it. We will study this in detail about catalyst and temperature also, that how they affect the rate of reaction, right? This we will study in detail in the end of this lecture. In the end of this lecture, we will talk about catalyst, we will talk about the temperature also, right? Now, next is rate law. Now, what is this rate law? As it is defined here, rate of the reaction is found to be dependent on concentration in a very complicated manner, But the simplest kind of dependence of rate on concentration of different species are as follows. So, how you can tell about the rate law expression? What is this rate law? They are saying that, for example, you have a reactant. This is one reaction is going on A to B. This is A, this is B. Now, the rate of the reaction is directly proportional to, right? This is by rate law expression, is directly proportional to the reactants raised to the power, any power that I am telling as n. It's not raised to the power the stoichiometry, right? Now this n is equals to the order. We can write it here. Now this n is called the order, right? And this may or may not be equal to stoichiometry. This can be equal to stoichiometry, means this n can be equals to A, or this n cannot be equals to A. That totally depends. It's not that full-fledged that this will be equals to A, right? It can be equals to A, it cannot be equals to A. That is totally dependent on the reaction. That is why we calculate this order in an experimental way. This is calculated in an experimental way. We do the experiment. After that, we see the dependency of rate on the reactant. Then we find out on which kind of like dependency it has. It doesn't matter what is the kind, what is the stoichiometry. It can be or it cannot be. It may be or it may not be. It totally depends, right? So now, if I am saying it may be or it may not be, let us talk about when it will be, when it will not be, right? So basically there are two types of reactions based on the number of steps involved. One is your elementary, or this is also called simple. Right? Simple reaction. Other is your complex reaction. Right? If you talk about elementary, that is a one-step reaction. If you talk about complex reaction, that is a multiple step. Right? So many steps are involved in this. If you have one step, that is called elementary. If you have multiple steps, that is called complex reaction. Now see, if you have only one step reaction, in that case, order is equal to the stoichiometry of reactants. Sum of stoichiometry. Order is equals to sum of stoichiometry of reactants, right? Okay. If you are saying it is a multiple step, then it may or may not be. Again, it is may. We can't say. It is not definite. May or may not be. Right? Now here the reason is that in multiple steps, for example, some reaction is occurring in 3-4 steps. So the step that will define the rate of reaction, you have studied this in SN1, SN2. Yes, you have studied this in SN1, SN2. I used to tell you the slowest step will be the rate determining step. So you will see slowest step will be your rate determining step. That will be your slowest step. Understood or not? The slowest step is going to be your rate determining step. Is it clear to everybody or not? Is this clear? Yes, ma'am, in SN1, SN2, we have studied that. Yes. So, let us talk about this complex reaction, because in elementary reaction, it is a very simple thing that your order will be equals to the stoichiometry. For example, I am saying this is A plus BB give rise to CC. And I am saying that this is elementary. This is elementary reaction. So here you will say rate is equals to, and also if you take out this proportionality sign, it will be rate is equals to K A raised to power N, where this k is your rate constant. This k is your rate constant, right? This k is your rate constant, right? So if you talk about here rate is equals to k, rate constant multiplied by reactants, and this is your products. Because this is a elementary reaction, right? So we will say that this, for example, I am saying this is x, this is y, right? Because of the elementary reaction, I am saying x plus y is equals to n, that is the order. And for elementary reaction, this order will be equals to a plus b only, right? This order will be equals to a plus b only, right? Because here we are talking about the slowest step, or you can just directly write it here, or you can just directly, because that one step is the rate determining step only. You can just directly write this is A and this is B. So order of the reaction will be A plus B. This is the elementary step. If this is not the elementary step, this is a complex reaction. In that case, things will be very different, right? Okay, things will be different in case of complex reaction. Let us see what will happen in case of complex reaction, right? Okay, let us see one question based on complex reaction, a very, very important question, okay? A very, this is NEET 2017 question, okay? This is NEET 2017 question. So let us see, right? Let us see, the question is, first step is A2 give rise to A plus A, right? Second is A plus B2, that will give rise to AB plus B, AB plus B, that is the slow step, that is the slow step. Third is A plus B, that give rise to AB, right? So these are the three steps. Now firstly tell me which is the rate determining step here. They are asking you the order of the reaction in the question. They will ask you the order of the reaction, right? So you have to tell me the order of the reaction. For that, tell me which is the slowest step here. Which is the slowest step here? Yes, student, which is the slowest step here? Everybody in the chat box, which is the slowest step? Hanji. Very good. Second is the rate determining step. Second is the rate, because that is the slowest step, right? So this will become your rate determining step. You can write here, this will become your rate determining step. Now this is your rate determining step. What you will do? Now tell me the order of the reaction. What will be the order of the reaction? What will be the order of the reaction? Any idea about it? Array beta, be little active. Yes. What is the order of the reaction? Roshni is saying 2. Okay. So what we can write from the slowest step, we can write the rate of the reaction, and the rate of reaction will be K into reactant. What is the reactant here? A and B. So on A you have only one stoichiometry, on B also, B2 also you have only one stoichiometry. So students will say, ma'am, order of the reaction is equals to 1 plus 1 is equals to 2. But I will say that is not the correct answer. That is not the correct answer. What is the reason behind that? The reason is that in your rate law expression, there should be no intermediate present, right? Very good. So in your intermediate reaction, those who have done the Newton has already done the previous year question, right? That's why he is telling that correctly. Yes, the order is going to be 1.5, right? Why the order is going to be 1.5? Let us see. Because in the overall reaction is A2 plus B2 give rise to, I forgot to write the overall reaction, okay? A2 plus B2 give rise to 2AB. That is the overall reaction. Right, this will be given in the question itself. This overall reaction will be given in the question, or you can just add all these things, you will get the overall reaction. You can just add all these things, you will get the overall reaction, right? Okay, so this is your overall reaction. So can you see that in the overall reaction, the reactants are A2 and B2. Nothing like A is mentioned in the overall reaction. That means this A should not be in the, it should not be in the, or in the rate law expression. So we need to substitute it. We need to substitute it. We need to substitute it, and now let us see how will we substitute it. I'll take it as this is my first equation, right? Now what I will do, I'll solve it in a different manner. So I'll take up one more reaction, whether first or third. That reaction should have A, but it should not have any other intermediate. If you talk about this third one, it has another intermediate, so I will not choose this reaction. Instead, I will choose this reaction. Moreover, this first reaction, in the question it will be mentioned that this first reaction will be in equilibrium, right? This first reaction will be in the equilibrium. So I'll choose this first reaction, that is A2, give rise to A plus A, give rise to A plus A. Now I am taking the equilibrium constant as Kc. So this Kc is equals to reactant by products, right? So reactant is A2, raised to the power the stoichiometry, that is 1. Product is A, and there are two products here, so it will be A square. So it will be A square, right? So it will be A square. Yes, Madhumati, I will drink that after this question, right? So this is A square. So I need to find out the value of A from there. So I will find the value of A, that will be equals to, A is equals to A2 multiplied by Kc, and this is your A square. So when you will take it here, it will become under root. So it will be, or you can just directly write it as this is A square, and A will become A2 1 by 2, Kc 1 by 2, right? A2 1 by 2, Kc 1 by 2. Now I will put this equation, this is my second equation. I will put second and first, what I will get? Put second and first. Put second and first, what you will get? You will get this thing, that rate of reaction is equals to K dot Kc 1 by 2. This is your A. This is your A2 half, and this is your B2, and this is 1. So now this is also constant, this is rate constant, and this Kc is your equilibrium constant. They will make one new constant, I will call it as K dash. So rate of reaction is equals to K dash A2 1 by 2 and B2 1. And what will be the order? Order of this reaction will be N is equals to half plus 1, that will become 1.5. So order of this reaction is going to be 1.5. Yes, students, so this was a very important question. I'll write it here. This is your NEET 2017 question, a very important question, right? A very important question. Understood this? Any problem in this question, right? It's a different one, right? Usually students just cram the formulas, right? They have no idea about that something like this question also exists, right? Okay. Hanji, everybody in the chat box, is that clear? Is that clear? Is that clear? Yes. Now, okay, that was here, no? Now, let us see the rate law expression we have done, right? This we have done. Now, one more thing about the units. Now, let us talk about the units. The units. 2 units I want to talk about. First is your rate law. There are 2 things in rate law. One is R, K, and this is concentration, right? So, firstly, I will define the units of rate. Units of rate. Units of rate are equals to, what is rate? Rate is equals to, if you define the rate, that is equals to change in concentration. Change in concentration divided by change in time. Change in time. So I can write the rate as, the units of rate are change in concentration. Concentration is expressed in molarity. Molarity is mole per liter, right? And the time can be in seconds. The time can be in hours also, or minutes also, right? the time can also be in the, there is no limitation on the time, right? The time can also be in hours, right? Okay. Usually you will see in seconds, but it can be in seconds, minutes or hours. But volume, as you have seen in molarity definition, volume will always be in your mole per liter, always. That is why I tell you that mole concept is important. Why? Because that is used everywhere. The concentration terms are used everywhere. Last, you have done the, wait a minute, I am just not able to understand. Should I switch on the AC or should I turn it off? It's the most difficult thing right now in my life in this change of season is to understand what should be my temperature of this AC. Totally. It's more difficult than chemistry, I feel. Okay. Now, next is, let us talk about the units of rate constant. Rate constant. So, I'll give you a very simple trick in the end, okay? So, units of rate constant, we know that from rate law equation, R is equals to, that is rate is equals to K, and this is concentration of reactants. I can write it by C raised to power N, where N is the order of the reaction, right? Okay, I am generally writing what should be this. So, here, can I say that K is equals to rate defined by concentration raised to power N. So, if you talk about the units here, units will be, what is rate? Rate is nothing but mole per liter per second. I am talking about per second here. Let's choose anything, I am choosing per second, right? You can choose anything, I am choosing per second, right? So, it will be mole, because usually you will define it by per second only, right? Mole per liter per second is the units of your rate. What is concentration? That is mole per liter. This is N. So, I can take the N above. It will be mole, because mole per liter is the common thing here. This is also mole per liter. This is also mole per liter. So, it will be 1 minus N. And this will be per second. Or, if you want to take it in hours, it will be mole per liter 1 minus N per minute. Or if you want to take it in hours, it will be mole per liter 1 minus N per hour, right? Usually you will see this thing. Mostly you will see this thing, right? Generally you will see mole per liter 1 minus N per second. Now where N is the order of that reaction. It can be 0, it can be 1, it can be 2, anything. N can be anything, okay? N can be anything, right? Okay. Guys, should I stop teaching? Tell me one thing. Should I just drop this pen and stop and go and turn off this class, end this class? Tell me one thing. Because I cannot teach like that, right? If you are not interacting, I won't be able to teach only. That's also not in my hands, right? That's how I am programmed, right? You should be like little bit something in the chat box, because I am not able to see your faces, right? I am only seeing that, okay, students are totally sleepy or whatever, right? I know that you are there, you are studying, you are focusing on the concept, but just write that thumbs up, that green heart, anything. I am not asking you to write down the paragraphs in the chat box, right? Do the shero shari in the chat box, right? Nothing I am asking you. I am just saying respond, right? Respond. That's it. Yes? Okay? Chal. Now that was the rate of that was the unit of rates. Right? Now let us see some of the important points regarding rate. Let us see some of the important points regarding rates. Oh my God. Wait. Wait a minute. Yes, it feels much better. Yeah. Okay. Very good, very good, very good. Now let us see the rate law. Let us see. Rate law for any reaction cannot be predicted by merely looking at the balanced chemical equation, because we cannot understand the order of that reaction. That's not possible, right? It can be determined theoretically. It cannot be determined theoretically, but must be determined experimentally, because order is determined experimentally, not theoretically, right? Next is the order of the reaction. We are going to understand few points regarding order of the reaction, right? Order of the reaction is sum of powers of concentration terms appearing in the rate law expression. For example, your rate law expression is this thing. This is your rate law expression. Then order of the reaction will be P plus Q. It does not depend on the reaction. If this is your reaction, doesn't matter. Your order should be the powers, the sum of powers in your rate law expression, the sum of powers of the reactants in your rate law expression. So this N will be P plus Q. N is the order of reaction. That will be P plus Q, right? Now, next important thing here is what can be the order, what can be the value of order of reaction? Order of reaction can be positive, it can be negative, it can be zero, it can be in fraction also, right? Order of the reaction has no limitation. It can be positive, it can be negative, it can be zero, it can be in fraction, right? So this is a very, very important point regarding order of the reaction. Regarding order of the reaction, they can ask you which of the following is not true for order of reaction. For that, you need to understand the important points for order of reaction. Yes, today complete chapter we will complete, ma'am. Yes, we will complete the full chapter today with the same enthusiasm, with the same energy that we started initially, right? If your energy is high, my energy is automatically high. If your energy is low, my energy automatically drops down. It's not even in my control, right? Okay, it's not like I am doing this intentionally. This happens when you are standing here, na, when ever, if ever in life you stand here and you teach someone, it totally depends on the students what will be the energy of the teacher, right? Okay, yes, very good. Now, the order of the reaction has another few more points. Order is always determined experimentally, right? As I told you already, that order we cannot just see the reaction and tell the order of the reaction, right? It should be either given in the problem or should be calculated by the problem, by the information. We will see that how we can calculate the order of the reaction with the information that is given to you. In the end of this class, when we will study about order 1 and 0, 1 and 2, right? Then we will, after the class, we will study about what should be the order of the reaction if we want to calculate the order of the reaction, right? Then you have rate law expression normally involves reactants, but it may involve catalysts as well as products. But reaction intermediates will never appear in the rate of reaction. For this also, we have already done a very important problem that your reaction intermediate will never appear in your rate law expression, right? Okay. Now, next is on changing the stoichiometry of the reaction, rate of reaction and rate constant changes, but rate of reaction of a particular substance remains same, right? They are saying that the rate of reaction can change, but the rate of appearance and disappearance will not change, right? Why? Because rate of reaction was dependent on the stoichiometry, right? We used to divide it by the stoichiometry. You remember rate of reaction was divided by the number of moles, right? But if we talk about the rate of appearance and disappearance, we have no link with the division of the number of moles or the stoichiometry. That is why if we multiply, if we change the stoichiometry, rate of reaction will change, but the rate of appearance and the disappearance will not change, right? Only for simple elementary single step reaction, very important. The order of the reaction is equals to stoichiometry coefficient of the reactants, as I have already told you. But if you have complex reaction, then it should be decided experimentally with the help of mechanism of the reaction, which will tell us the rate determining step here, right? Okay. Okay. Understood? Units also, students, we have already done. So I am just deleting this slide here, right? Units we have already done. Now, when we did the units, right? When we did the units, I told you that units of rate constant is equals to mole per liter. You don't even need to do this, right? Mole per liter 1 minus n per second, right? 1 minus n per second. Now understand one thing. If your order n is equals to 0, if n is equals to 0, then that will be mole per liter per second. If n is equals to 1, if you put 1 here, 1 will cancel out. Anything raised to power 0 is 1 only, so answer will be per second. If n is equals to 2, in that case it will be liter per mole per second, right? Because here it will be minus 1 then, right? The things will be opposite. It will reverse. Minus 1 multiplied by mole, it will be per mole. Minus 1 multiplied by minus 1, it will be liter, right? Okay, so you don't need to do this thing. Just remember this mole per liter 1 minus n per second. Just put the value of n is equals to 0, 1, 2 according to the order that is given to you, right? Okay, Tanuja is active, fully active here. Sneha is also fully active here, right? Now, next is molecularity of the reaction. Now, what is this molecularity of the reaction? Molecularity of the reaction is determined by the number, the molecules that are colliding with each other and forming the products. The reactants that are colliding and forming the products will define the molecularity, right? So, very important point regarding molecularity and the difference of molecularity in the order. They ask you theoretical based question, right? Okay, the number of reacting species taking part in elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called the molecularity of the reaction. Now, molecularity, unimolecular reaction, when only one molecule you have, right? That molecule is colliding with the other molecules of the same thing, of the same compound. It will dissociate, like it is basically a decomposition reaction. It will dissociate and give us the products. Now, if your molecularity is 2, answer will be, for example, you have 2 HI. In this, these 2 molecules will react and give us the products. Here the molecularity is 3. In this case, 3 molecules will react and give us the desired products, right? Okay. So now, let us see some very, very important points regarding molecularity. The probability that more than 3 molecules can collide and react is very small, right? Because more than 3 molecules, it is difficult because of the steric factors. There will be a lot of, big molecules. There is one big molecule, one big molecule, one big molecules. So more than 3 molecules, only if the molecules are very small only then that is possible. Otherwise, the probability of them colliding and making the products is very, very small, right? Second is, reactions with molecularity 3 are very rare and slow to proceed. Next is complex reaction involving more than 3 molecules in the stoichiometric equation. They are saying complex reaction which involving more than 3 molecules in the stoichiometric equation. For example, this is more than 3 molecules. It is not necessary that all of them will collide with each other. Must take place in more than one step. Okay, and that means they are saying rate determining step. Rate determining step is different. They are saying that if in the overall reaction you have these many reactants, so it does not mean that, ma'am, you have 6, 7, 8, 9, 10. 10 molecules are colliding with each other. That's not the possibility. It's not even possible. In reality, it's not possible for 10 molecules collide with each other. It's not possible for 10 molecules. Not possible, right? So that is why they are saying that if you have so many molecules, more than 3 molecules in overall reaction, you can see that this will not be the rate determining step. Right? Rate determining step is something else which will have maximum 3 molecules in the rate determining step, right? This reaction, which apparently seems to be 10th order, is actually a second order reaction. right? That means in the rate determining step, you have only 2 reactants, and this is the overall reaction. Yes, very good. Now, next is in a complex reaction. In a complex reaction, you have different steps. Rate determining step will tell us how many reactant it has, and that will tell us the molecularity. The overall rate of the reaction is controlled by slowest step in a reaction, that is called rate determining step. For example, here they have given you one example that this is your overall reaction, but actually the slowest step is this one. The slowest step is this one. In the slowest step, you have H2, O2 and HI and I negative. So if you see, if you want to write the rate in the form of overall reaction, you will see K is equals to H2O2, ma'am, it is 2. But this is not the correct way of writing it. We want to write the rate in the form of slowest step. So in the slowest step, if you want to write the rate, R is equals to K. The reactants are H2O2, this is the slowest step, H2O2 raised to power 1 and I negative raised to power 1. That will be the rate of the reaction, right? That will be the rate of the reaction. Okay, students? Yes, everybody in the chat box, is that clear? So shall we start with zero order, first order reaction or not? Shall we start with zero order, first order? Zero order reaction we will do, right? After that we will do first order reaction and then I will give you the break, okay? Or let's do one thing, firstly let us do zero order reaction, then we will see. And because, you know, this chapter is actually very simple, right? The most important part is zero order and first order reaction, right? Most important part of this chapter. Very good, Bhavna, Sneha, Dora, Dream, Tekko. Very good, Madhumati, Sid, Newton. Numericals, Harish, very good. Numericals, I have taken up some previous year questions, right? We will do those questions after. Firstly, let us complete this zero order reaction, right? Okay. Now, what is a zero order reaction? If you want to write down the rate of a zero order reaction, how you will write the rate of a zero order reaction? Now, we know that rate is equals to K into reactant and this is raised to power N, right? This is raised to power N, right? So, can I say that, okay, if I want to write the reaction, it is A to B. Initially, I am saying that it is having A0 and finally it is having AT, right? And this time is T, this time is 0, this time is T, right? Here time is equals to 0 and here time is equals to T seconds, right? Now let us write the rate of the reaction. Rate of the reaction according to rate law expression is K A raised to power N. Now we know that the order of the reaction is 0. If N is equals to 0, that will be R is equals to K A raised to power 0. This is 0, so this will be K. This 0, anything raised to power 0 is 1 only, so R is equals to K, right? R is equals to K, right? So can I say that R is equals to K? This is R is equals to K A raised to power 0 and this will say R is equals to K, right? Okay. From rate law expression, this is the answer for zero order reaction. Now, from your first thing, that is rate of reaction in the form of differentiation, what you can write? Yes, in the form of differentiation, what you can write? In the form of differentiation, you can write what is in the form of reactants I want to write. So, I can write minus of dA by dt equals to K. Isn't it? Can I write this thing here? Can I write this thing here? If dt will come to this position, it will be minus dA is equals to K dt, right? Is equals to K dt. Now, I will do the integration here. I will start doing the integration here. For integration, I should know that the initial to final. Initially, it is A0 and final it is AT. Initially, it is A0, final it is AT. Initially, it is 0. Initially, it is 0. Finally, it is T. Finally, it is T. So, I'll just do the integration, right? I'll just do the integration. Now, this is your minus. This is integration 1 dot dA. When you're talking about integration of 1, that is a constant, right? What will be the answer? The answer will be A from A naught to A. That will be the answer of 1 dot dA. Integration of nothing is this. Integration of nothing is this, right? So there is 1 multiplied by that dA. So answer will be minus of A. A is from A naught to A, right? And what is this integration of this thing? Again, K is a constant. We will take this out. Again, 1 dot integration dt. That will be T from 0 to T, right? So what you can write here, that this will be minus of A minus A naught equals to K T minus 0. So here it will be KT, and here it will be A naught concentration minus A. So that is going to be the final equation. This is a very, very important equation. That is going to be the final equation for zero order reaction, right? That is going to be the final equation for zero order reaction. Okay? Zero order reaction, this is the final. From this equation, we will derive so many things around, right? Okay? So, firstly, I want to draw some graphs, okay? Firstly, I want to draw some, okay. So, firstly, let's not draw a graph. Let us write the formula for T half of the reaction. T half, when 50% reactant is consumed. When 50% reactant is consumed, they can directly ask you the T half, right? I will give you a direct trick of the T half as well, right? So T half of the reaction is when 50% of it is consumed. That means A is equals to A naught by 2. So you can write it here. That will be A naught minus A naught by 2 is equals to KT half, and that will be equals to A naught by 2 is equals to KT half. So T half will be equals to A naught by 2K. A naught by 2K, that is the T half for zero order reaction. This is the formula. If you don't want to remember anything, you just remember one thing. That is the formula, that is the equation for zero order reaction. That's it. If you know this thing, you can easily calculate T half. Right? T half is equals to A naught by 2K. Okay. T half is equals to A naught by 2K. Again, this is very, 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 very important. Right? Very, 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 very important. Now, we have calculated the value of T half here. One more thing. Let us do the graphs here. Let us do two very important graphs here. From the equation only I will write. So, this is your A naught minus AT is equals to KT. So, if I am taking it as Y, if I am taking this as Y, Y is equals to, this is your X, this is M plus C. Now, here C is equals to 0, C is equals to 0, M is equals to K, X is your Y axis, that is T, and Y axis is this one. Y axis is this one, that is A naught minus this. So, I am drawing the graph here, I am drawing the graph here. The graph will be, if on the Y axis I have A naught minus AT, right? And this X axis is your time. Answer will be, intercept is 0, that means it will start from the 0 position. That means it will start from the 0 position, right? From this intercept is 0. Now, it will go up to when your slope is K. Right, when your slope is K, right, when your slope is K. Now, the slope is K, slope is K. Understood? Right? So, now don't cram the graphs, right? Instead, try to understand the graph. This is a straight line equation, right? Y is equals to mx plus c, right? Now, if they are asking me that you need to draw a graph between final concentration and time, so it will be AT. If I want to write the formula in that format, it will be AT, I can take here, it will be AT equals to KT. So take this here, equals to A naught plus KT. or I can also write it as KT plus A naught. Plus A naught, right? So if I compare this with y is equals to mx plus c, this is y equals to, this is m, this is x plus c, right? This is m, this is x plus c. Wait a minute, here it should be minus, right? Because if I take this on this side, it will be plus. If I take kt on this side, it will be minus, right? So it will be minus kt plus a naught, right? So can I say that here m is going to be minus k, x is going to be t, y is going to be at, and c is going to be a naught, right? So let us draw the graph here. Let us draw the graph here. The graph is between y and x. Y is what, your at, and x is your time, right? X is your time. So tell me what will be the intercept. What will be the intercept? From the equation itself, tell me what will be the intercept. I have already written here. I have already written the intercept here. The intercept is c is going to be a naught, right? So intercept is when that line touches the y-axis. So I am taking this as the intercept, right? They are also saying that the slope is negative. Here the slope was positive, that is k, so that the graph was up. But here the slope is negative, so graph will be down, right? So here I am taking the intercept as this point, right? So I will draw the graph here. I will draw the graph here like this, right? Like this. Here I can write the slope is minus k, right? What is x-axis? That is time. Y-axis is t. What is the intercept? Intercept is your a naught. Intercept is your a naught. Okay, intercept is your a naught. Very good, very good, very good. Negative slope we will have here. So these are the most asked question regarding graph, right? If you want to write more graphs here, let us see more graphs here. More graphs if you want to understand. All the graphs that they can ask you, I have mentioned it here, right? All the graphs, maximum graphs that they can ask you, I have mentioned it here itself, right? Apart from this, they will not ask you any other graph, right? Most probably they will ask you this only, but if they want to make it complicated, not complicated, I would say, if they want to test your knowledge, they can ask you this one also. So here we are writing that graph between rate and time, right? So we know that for rate and time, it is rate is equals to rate constant. So between rate and time there is nothing, so it will be rate is equals to rate constant. So r is equals to k. With the time there is no effect, right? So it is a constant thing. R is equals to k, right? And this point will be called as k. If you talk about the concentration of R and A, right? The concentration, right? Here we are saying the concentration. With concentration there is no change, right? With concentration also, because you are talking about rate here. Rate is equals to k into a naught. A raised to power 0. That will be R is equals to k, right? So that means with concentration also there is no change. So here R is equals to k, right? That is a constant thing according to concentration also. If they are asking you this, so we have already done. A naught minus AT is equals to KT. This we have already done. This also we have done. This also we have done, right? If they ask you X, what is X? X is the final concentration, right? If they ask you X, X is the final concentration, that you will write it as final concentration is what? Wait a minute. What will be the final concentration? Wait a minute. Let me see if they have taken it as final concentration or what. They have taken X is equals to A naught minus AT, right? From A naught minus AT, they have taken it as X. So X is nothing but it is A naught minus AT. So if we talk about A naught minus AT, that will be the same graph, right? Now here they are talking about A and T. Not A and T, they are talking about alpha and T, right? Between alpha and T, what will be the answer? Now what is alpha? Everybody in the chat box, what was alpha? We have done this in chemical equilibrium. Alpha is your degree of dissociation, right? So degree of dissociation is equals to the number of moles dissociated. How many number of moles dissociated? That is equals to kT. These are the number of moles that are being dissociated. Tell me one thing. If I am talking about this is my initial, this is my final. So number of mole dissociated will be equals to number of moles dissociated. Dissociated will be equals to initial minus final, that is A0 minus AT. Right? What is A0 minus AT? They are taking it as X. Right? They are taking it as X. So this is a very, very important graph, because alpha is equals to A0 minus AT, that we will define it as KT, right? And what are the initial moles? That is equals to A0. If you draw a graph between KT and A0, the answer will be this thing, right? Okay, you can just compare this here, right? So T is your this thing, right? This is your T, this is your X, this is your Y, plus C, intercept will become 0, and this will become your slope. This will become your slope, that is equals to M, right? This thing will become your slope. Alpha is equals to KT by A0. Students, tell me, is this thing clear to you or not? What is alpha? That is the number of moles dissociated, right? Initially what we had? Initially we had A0 and final we had AT. So how many moles are dissociated here? That is A0 minus AT. These many moles are being dissociated, right? They have been taken from the initial thing. These are the number of moles that they have been taken out. Right? These are the moles that have been dissociated, right? So what is your A0 minus AT? That is KT, right? A0 minus AT is what? KT. So that is number of moles dissociated by initial. So we will compare it with the straight line graph, that is Y is equals to mx plus C. C is 0. That is why it is starting from the 0. Slope is K by A0 and your x-axis is your time, right? That is how we have drawn this graph. Yes, very good. Now, next is this very simple thing about zero order reaction that they are telling. That for zero order reaction are relatively uncommon, but they occur under special conditions, right? For example, the decomposition of gaseous ammonia. If you talk about the decomposition of gaseous ammonia in presence of catalyst, on the surface is zero order reaction at high pressure. Next is the thermal decomposition of HI on gold surface is another example of zero order reactions. So zero order reactions are basically decomposition reactions only, right? Okay. Now half-life of zero order reaction we have already done. That half-life is equals to it is equals to A0 by 2K. And if you want to write it here, write here general formula is T half is directly proportional to A0 1 minus N. This is a general formula, right? If they ask you the dependency of T half of any order, very good. I love to, when I see this in the chat box, that makes me happy, right? So when we talk about a zero order reaction, here put N is equals to 0, you will have this directly proportional. You put N is equals to 1, 1 minus 1 is 0, anything raised to power 0 is 1. Then you will see that in half order reaction, in half-life of first order reaction, it will be independent of the initial concentration, because when you put this as 1, it will be T half is directly proportional to A0 1 minus 1, that will cancel out. It will be A0 raised to power 0, that is nothing but it is 1. So that is not directly proportional to A0. So right, so this is a general formula. It is a very, very important thing, very, very important thing. That is why I am writing the general formula also here in your short notes, right? For example, I have these flashcards, okay? I have these flashcards with me. Now, if I talk about these flashcards, what is written in these flashcards? Only these general formulas, right? The direct relation, so that, because in the exam, what is the difficult part? Firstly, you have understood the concept. Now to revise the things, you need to have something different, right? So these are the flashcards that you will have. In these flashcards, for example, if I talk about this flashcards, I don't know if that is visible to you or not, because things will be blurry here, right? So what will happen in this case, you will have everything, right? Everything, the electronic configuration, the exceptional trends. Here you will have the colors of different compounds, right? Then you have different catalysts that are used in different application processes, right? Then all these things are mentioned in your flashcards, right? Okay, so I would advise you to purchase these flashcards because they are currently, wait a minute, they are currently on offer. So that's why, that is my advice, that on this Diwali you can ask your parents for this gift to you, right? Because that is going to be very beneficial for you, right? These kind of short notes is all you need for your revision sessions. So that is why these flashcards are at 1321, right? 1321, right? Earlier it was 111999, right? But now the discounted rate is 1321, and for this 1321, such a big hard work, right? Already we have done for you, right? All chapters combined in these little flashcards. That's it, right? So this is very good for revision, right? Whenever you are giving mock test, this is a very interesting thing, right? And from these flashcards, you will be able to remember everything, right? Okay, so right now it is at offer, and offer is only valid till Diwali, that is 1st of November, I think 2nd of November. After that, the offer will not be valid, and we will deliver this flashcards at your home itself, right? So what you have to do, the link is in the description. You just have to click that link and you can go and purchase that flashcard, right? Okay, next important thing is, if you want to purchase Tejas books, right? What is Tejas books? I'll show you what are these Tejas books. So these are basically the Tejas books, right? Now we are just 5 to 6 months away from NEET. So two things are important for you right now. First is your revision. For revision, we have flashcards for you so that quickly you can revise the things. After revision, what you need to do next? After revision, you need to practice a lot, right? After revision, you need to practice a lot. So these are the, as you can see, this is past year questions, right? In a very beautiful manner, they have also mentioned everything here, right? Now, next is the solution of these chapters, right? NCERT based questions are there, right? In detail, the solution is given to you. Now, not only this is for your question answer, but this is also for your simple, in a table form, your short notes are given to you, right? Okay, so, but in flashcards, definitely, in just one page, you will have so many things. In these short notes, it is in detail, right? But still it is like short notes in detail, little bit detail will be there, right? Some mechanisms will be mentioned here. But in flashcards, direct reaction, so that the things that you need to cram, those things are mentioned in the flashcards. For example, your naming reactions, your important intermediates, then there is formulas, right? Exceptions, all of these are mentioned, right? But this book is going to be for your practice, right? A lot of practice you can see from this book, and I think now still you have time for practice, so don't get late here, right? Don't be late. Now, after, if you say in January, ma'am, I want to practice, I will say yes, you can definitely practice in Jan as well. But you know what is the difficult part? Now you can work on your mistakes. In Jan, if you identify that I am not good in these many chapters, right? In physics also, I have these chapters which I am not good in. In chemistry also, in these organic chemistry reactions, in organic chemistry mechanism, I am not good at that. So how you will have time to improve yourself? Right now, you have time to improve, to focus on your weaknesses, right? So that is my advice. Please start practicing now. Buy this flashcard for your revision, and after that, do the practice, and then have a notebook of your mistake notebook where you are going to write all your mistakes, right? And then work on those mistakes. This is the best way so that you can crack your NEET exam, right? Now, those students who are like, ma'am, I am not enrolled into the DNA batch, I also want DNA batch along with the Tejas books, right? So best way is to have this combo. You will purchase DNA batch individually, you will purchase Tejas books individually. Instead of that, purchase these two things simultaneously, and it is at 2999. The offer is 2999. You will get your DNA batch. In DNA batch, you will get everything. You will get Tattva books, right, but in PDF form. You will get DPPs. You will get this 150 books for your revision, for your quizzes. Then also one thing I forgot to tell you. Yeah. Yes, you will get no doubt I was not there. I totally forgot to tell you that. Yes, in DNA batch full syllabus. Yeah, I'm like, how can I forget that important thing? Yeah. So mock test you are getting this Sunday itself. Some students in DNA batch, they attempted for mock tests, and some of them asked me, ma'am, that I am weak in these things, right? Now they already know their weaknesses, right? So students were saying, ma'am, in thermodynamics, I'm finding it very difficult to answer, like to identify which is the formula that I should use. But when they were doing thermodynamics, they were happy about it. But now they know that they are not able to recall the formulas, right? They know that they are weak in that portion and they are working on that portion, right? So you give the mock test, then you can ask me that these are the things that I am weak in, then so that you can work on that, right? So mock test will also be there. So now it's totally your choice what you want to have, right? Okay, yes. Okay, now wait a minute, where we were at this point, right? We were at this point. Now, students, a very important point about T half for your zero order reaction, a very important point here is that if you talk about a zero order reaction, for example, initially it is 100%, right? After T half, it will become 50%. After T half again, it will consume rest of the 50%, it will be 0%, right? So we can say that your, when full of this is consumed, right? So when you have like 0% left, right? 0%, that means your 100% is consumed here, right? 100% is consumed here. So you can say that T 100% is equals to 2 into T 50%. 2 into T 50%. For example, I am saying that here you have 100 molar, here you have 50 molar, and here you have 0 molar. Here how much amount is consumed? 50% is consumed. And here it is equals to 2 into T half. This is only applicable for zero order reaction. This is not applicable for first order reaction. What I am saying, that in zero order reaction, if you apply T half here, when 50% of the concentration is consumed, and then after with the remaining 50%, again you give it T half time, then what will happen? Rest of the 50% will be consumed and you will have zero concentration in the end. So when your 100% concentration is consumed, that is equals to 2 into T half, because 2 T half it will take to consume 100% of the concentration, right? So this is only applicable for zero order reaction. This is only applicable for zero order reaction, right? Zero order reaction. Okay? Okay, students? Yes. Now, 2-3 important things about this. I'm just writing the direct formula here. T of 75% is T of 50% in terms of T of 25%. Yes, T of 25%. Right? I want to write it down in the form of T of 50, that is T half. Right? So what I will write? Here it will be multiplied by your 1.5, right? And here it will be multiplied by your 0.5. Right? This will be multiplied by your 0.5. Right? Why? Because if you want to have only 25%, you want to consume not 50%, you want to consume 25%. Now 25% is half of 50%. That will lie somewhere here, right? That is why the T half will be 1 by 2. That is why here we have written 0.5, that is 1 by 2. Right? Because what is 50%? If you instead of half, you want to write 50% here. You want to write 50%. Here also you want to write 50%. Right? So in case of zero order reaction, T25, because 25 is half of 50. That is why their time is also half. Right? And in this case, if you want to see this, where 75? 75 will lie somewhere here. Here 75% will lie, here 25% will lie. 75% consume means T half, T half and T half, right? That means here you will need to have how many T halves? 3 T halves. That is why I have written 1.5. That is 1 plus half. 1 T half for this one and half T half for this one. That will become 1.5, right? That will become 1.5. Now tell me, is this thing clear to everybody? Is this thing clear to everybody what I want to tell you? Right? Is this thing clear to everybody? Right? Okay. So what we are saying in zero order reaction, right? From concentration when 50% is consumed, the concentration will be also half. If further 50% is consumed, the concentration will be half of that. That will be, you will have like no concentration will be remaining, right? Now, if you talk about 25%, that is in the middle of this. That is why T is also half here. T is also half of this 50%, right? If you talk about 75%, that is somewhat here. That is why it is 1, 2. This is half T half, half T half and half T half. Or you can say this is full T half plus half of T half. That will become 1.5, right? Okay, that will become 1.5. Now, let us talk about some questions, right, from your zero order reaction. They are saying when the initial concentration of the reactant is doubled, the half-life period of zero order reaction. When the initial concentration, if the initial concentration of the reactant is doubled, the half-life period of zero order reaction, T half is equals to which thing? That is equals to, if you want to write the direct formula, that is TA naught 1 minus N. For zero order reaction, T half is equals to, is proportional to A naught raised to power 1. Or you can just directly write the formula T half is equals to A naught by 2K. If you double the initial concentration, then it will be 2A naught of 2K. Now this will become your initial. So it will be T half. This is 2 into initially T half. So it will be doubled, right? So wait a minute. The initial concentration of the reactant is doubled. The half-life period of the zero order reaction. If the initial concentration is doubled, the half-life period of the zero order reaction. They are not asking you the time, is it? They are not asking you the half-life time. Wait a minute. Then it is, yes. So it is doubled. Right? So answer is B. Right? Answer is B. Okay. Sometimes they don't ask you the time, T half. Sometimes they ask you the rate. Rate is not dependent on initial concentration. If they ask you the rate, rate is not dependent on the initial concentration. Rate is equals to K only. Rate is equals to K only. So be careful what they are asking you. If they are asking you the rate, that is not dependent on the initial concentration. But if they are asking you the T half, that is dependent on the initial concentration for zero order reaction. Right? For zero order reaction. Now let us talk about first order reaction. What is this first order reaction? Let us draw. Let us firstly see the first order reaction, right? Okay, let us see the first order reaction. So what is first order reaction? When, if you talk about the rate law equation, I'll say R is equals to K A raised to power N. Order is first order, so it is K A raised to power 1. It is R. Now what is R? R is equals to, everybody in the chat box, what is this R? R is nothing but minus d A by dt equals to Ka. Ka. If you take A here and A on this side and T on this side, it will be Kt minus dA, or you can say this is 1 by A dA, and you do the integration of this thing. You do the integration here. Now after integration, what will happen? After integration, we know the initial is, let us say initial is A naught, final is AT, right? Here initial is 0, final is T. Initial is 0, final is T. So what is the integration of 1 by a dA? Integration of this. Everybody in the chat box, anybody in the chat box? Right. Yeah. Now, what is 1 by a? What is 1 by integration of 1 by a? What is the integration of 1 by a? Simple, yaar, it is log, natural log of a. The integration is natural log of a. So you will write here, this is minus natural log of a, and this is going from a naught to at equals to, this is k, and this integration is t only, this is going from 0 to t. So this will become kt only, this will become minus of natural log of at, this is minus of natural log of a naught, final minus initial, right? So this will be a naught, natural log of a naught minus natural log of at equals to kt, right? Equals to kt, right? Equals to kt. So now this will be your final equation, right? This is the first equation. I'm writing different forms in which you will see the first order reaction. Next is, if you want to write it in this form, natural log of a naught by at equals to kt. You can also see this in this form because we know that natural log of a minus natural log of b is equals to natural log of a by b, right? So that is why that will be natural log of a naught by a is equals to kt. That is your second way of writing this equation, right? The third way of writing this equation, first two ways I am writing here, natural log of a naught, natural log of a is equals to kt. Second way is natural log of a naught by at equals to kt. Third way is writing it in the form of log base 10. So log base 10 a naught by at equals to kt by 2.303, right? That will be the third way of writing this equation, right? That will be the third way of writing this equation. So in these three forms, you can see the equation of first order, right? First order reaction, right? Okay. Now we will see what is T half for this. Now we will see what is T half for this. T half is when A is equals to A naught by 2, right? So just put the value here. I will, because I know the value, no, I don't know the value of natural log, right? We know the value of log base 10. So we will calculate this T half with the help of this formula. Now whenever you are solving any equation, you will use this formula, right? Whenever you are using any, you are doing any numerical, you will use this formula. This is for numerical purpose, right? This is for numerical purpose, right? You will use this formula for the numerical purpose, right? Okay. But if you want to talk about graph, for graph, you can use any of these formula depending upon what they are asking you, right? Okay. So now, let us use this formula. This is log base 10. This is log base 10. What is A naught? What is A naught? I'll draw one more line here, right? Reason being, there is also one more method of calculating T half. So this is log base 10 A naught, and this is A naught by 2. So this will become A naught, and this is multiplied by 2 equals to KT half equals to 2.303, and this will be log base 10 of 2 multiplied by 2.303 is equals to K. This is T half, and this will be divided by K, right? And when you solve this equation, this will become 0.603 by K. That will become your final answer. Okay? Okay, that will become your final answer. Log base 10 2 is 0.301 multiplied by 2.303. Answer will be this one, right? Now, if you want to calculate in the form of natural log, so you can use this formula. That will be natural log of, because this also has been asked, right? That's why I am writing it. A naught multiplied by 2. This is KT half. Now this will cancel out. This is natural log of 2 and t half is natural log of 2 by k, right? And it is independent, very, very important thing, independent of independent of concentration. It is independent of the concentration. Very 693, no? Yeah, it is 693. Yeah, it is 0.693. 0.693, right? Okay. So it is independent of the concentration. If you put the same thing in that generalized formula that I told you, that T half is directly proportional to A naught 1 minus N. So if N is 1, so it will be 0. Anything raised to power 0 is 1 only. So T half is independent of the concentration, right? Okay, for this, so you have to learn the formula, because directly they can ask you, they can give you the rate constant, they can ask you the value of T half here, right? Okay, students, very good, very good, very good. Tanuja is always motivating, ma'am. है ना? Tanuja is always motivating, ma'am. Like, ma'am, buck up, ma'am. Yes, ma'am, you can do it, ma'am. Tanuja is telling me that, ma'am, yes, we are awake. We are there. We are listening, ma'am. We are totally awake. Okay, so that is your formula. Now, next thing is, for first order reaction, firstly, let us see the graphs. Okay, then we will talk about the half-life. Okay, then we will talk about other things. Okay, firstly, let us see the graphs. The graphs are, if you want to draw the graph of rate and time. So with the time, rate and concentration, we know that R is equals to Ka, right? We know that, no? R is equals to Ka. This is what I have written here. R is equals to Ka. If I want to draw a graph between Y, if I take this as Y, this is Y. If I take this as Y, this is Y is equals to mx plus c. So intercept is 0. Here it is this. So the graph of rate and A is going to be, intercept is 0. So that is going to be a slope with K. K is the slope and it is going to be a straight line which is not parallel to x-axis. So that is the first graph that they have drawn. Second is, they are asking you to draw a graph between log base 10 A naught of A naught by AT and T, right? So log you need to have, and from that you want to calculate between T and log this, right? From this we have this particular formula, that is log base 10 A naught by A, right, or AT is equals to small or capital, whatever you can you want to take, it's totally your choice, right? That will be equals to KT divided by 2.303. And they are asking you for A naught or what? They are asking you for A naught on this only, right? So now let us see, if you want to take this as Y, this as your Y, this is your X, this is your X, this will become your M plus C. C is equals to 0, right? So the graph will be like this. The graph will be like this. Here your Y is log base 10 A naught by AT. T is the time. Intercept is 0, so it will go from the origin, right? And this is your slope, which is positive, right? Right? And here slope is equals to K by 2.303. This is the graph that they have drawn here, right? This is the graph that they have drawn here, right? Next is between natural log A naught by AT and T. Natural log A naught by AT and T, right? Natural log A naught by AT and T, right? If you want to draw a graph between that, then we know that natural log of A naught by AT. I could have just shown you the graphs, but I am drawing some of the graphs here, right? So this is KT, right? We know that this is Y, this whole is Y, right? This is your M, this is X, and C is 0, intercept is 0, right? So here let us draw the graph. We know that it is T, X is T, this is natural log A naught by AT, intercept is 0, so it will go from the origin, right? And slope is your M. So slope is your K. Rate constant is the slope. They can ask you that draw a graph between the graph between this and this. What is the value of slope? Right? So simple questions are asked regarding graphs, but graphs are very important for this chapter. Very important. Right? Now, next is this also we have done. Right? Now, if they ask you between natural log of AT minus A0, they are asking you the graph of natural log of AT and T. Natural log of AT and T. If you want to draw, they want you to draw a graph between natural log of AT and T. The graph they are asking is between AT, natural log of AT and T. We know that the formula is natural log of A0 by AT equals to KT. So can I say natural log of A0 minus natural log of AT is equals to KT. So if you want to talk about natural log of AT, that is equals to natural log of A0 plus or minus KT. Right? Okay. So it will go to this side, right? So here I am taking this as Y, this as my X, this as my M, and this as my C, right? So slope is negative here. Slope I am saying is negative here, right? Intercept here is natural log of A0. That is the intercept. Slope is negative. So it will go this direction. Slope is going to be minus K, right? And this is your natural log, and intercept is going to be natural log of A0. That is your intercept, right? They can ask you the intercept, they can ask you the slope, anything they can ask you, right? Anything they can ask you. Okay. Students, tell me, are you able to do it yourself or not? Are you able to draw the graphs yourself or not? Right? Okay. Now, this also we have drawn. Next is log base to 10. Next is log base 10 AT and T. Log base 10 AT and T. Right? Log base 10 AT and T. So the formula will be log base 10 A0. I'm not writing base 10 again and again. So this is A0 minus log AT equals to KT into 2.303. Right? You want to draw a graph between this. So it will be log base 10 AT equals to log base 10 A0 minus KT by 2.303. Right? So now let us draw the graph here. So the graph is going to be, everybody in the chat box, what is going to be the graph? Yes. Everybody, what is going to be the slope here? Everybody in the chat box, what is going to be the slope? What is going to be the slope? I want you guys to answer this, right? So this is my Y. Y is equals to, this is my M. This is my slope, M. This is T, X-axis. This is your intercept C, right? So here, if you want to draw the graph here, so this will be lateral log base 10 AT. This is time. The intercept is C. That is log A0, right? And what is the graph? Slope is negative here, right? So it is going to be, this is log base 10 A0. And what is the slope? Slope is minus K by 2.303. Right? Yes, very good. Minus K by 2.303. Straight line with a negative slope. Okay, straight line with a negative slope. Right? Okay. So these are the graphs that they ask you usually, this and these two graphs. But now I am drawing some graphs which have very less probability because they are in the exponential form, right? So for exponential, you need to draw it in the form of exponential. How you will draw it in the form of exponential? See one thing, we know that natural log of, or I can draw it on the next page, natural log of A0 by AT is equals to KT. If you take the exponent of that, log and exponents, natural log and exponential are opposite to each other, okay? Natural log, like integration and differentiation, are opposite of each other. In the same way, exponential and natural log are opposite of each other. If you take the exponential here and here, they will oppose each other. So answer will be, this will be, wait a minute, this will be, wait a minute, if I want to have the formula of 80, no. Chalo. Let's take the exponential here, exponential, let's take the exponential here. So it is going to cancel each other, and this will be a naught by 80. And for exponential of this is going to be e raised to power kt, right? Basically, if you want to write it in the full-fledged form, this will be, I'm drawing this thing here, right? So this is natural log of a naught by 80 is equals to kt. You take the exponent here, so it will be e natural log a naught by 80 is equals to e kt. They will cancel out, and this will form a naught by 80 is equals to e raised to power kt. Now, if I want to do the reverse, right, taking the opposite, this will be 80 by a naught is equals to 1 by e raised to power kt. And this will become e raised to power minus kt. That means at is equals to a naught e raised to power minus kt. Right? The same way we know that, that y is equals to mx plus c, ma'am. This is a straight line graph, right? We know that this is a straight line graph. In the same way, this equation, when you have a value is equals to initial value is equals to e raised to power minus of that. That is a graph of exponential, and that is going to be like this, right? This is going to be like this because here you have minus of kt, right? Here you have minus of kt, right? Here this is going to be your y, this is y, this is going to be your x, right? And this thing is going to be your m, right? Okay. And this a naught is the intercept. So basically y is equals to c e raised to power mx, right? Okay. So this c is your intercept a naught, right? And this is going to be your negative slope, that is minus k. And because it is not a straight line graph, it is an exponential graph. So it is a curved graph, right? When we are saying that the growth has increased exponentially, that means suddenly the growth has increased. So suddenly you will have this graph down or above, right? Okay. Yes, understood. Now, if you talk about the next thing, here you just need to just understand this as it is. So basically, if you have x is what? A naught minus, or you can say at minus a naught, right? So that is equals to e 1 minus e raised to power minus kt, and here the graph is going to be positive like this, right? Here the graph is going to be positive like this, okay? If you talk about this graph, alpha is equals to 1 minus e raised to power kt. Now this is also going to be a positive graph like this, right? Because the slope here is, here we are going to write that alpha is equals to 1 minus e raised to power minus kt, right? Okay, so that is the direct graph, but they will not ask you this graph, right? Maximum they can ask you this one, and this also has a very rare chances, right? This also has a very rare chances. Most probably they will ask you this graph or this graph or this graph, right? These are the three cases, and this also. They can ask you these 4 graphs, right? Okay, yes. Exponential decay, exponential above, right? Now let us see the first order reaction. I am deleting this only because that they are not going to ask you this thing, right? So next is first order reaction. Now very important thing, all problems related to radioactive. Now where you can see the first order reaction. First is in the radioactive decays, you can see nuclear physics or nuclear chemistry, right? I think you have done nuclear physics, right? Nuclear chemistry though is not in your syllabus, right? But nuclear physics you have done, is it? Share sir was telling me that you guys have done nuclear physics, something alpha, beta particles, right? Right? You have done that, is it? So in that case, you use first order reaction. You must have understood that there you use first order reactions only. Whenever you have nuclear decay, you have nuclear fission fusions. In that case, you use first order reaction, okay? Because these are first order reactions only. Second is growth or decay of bacteria. Third is acidic hydrolysis of ester. These are some of the reactions, some of the examples of first order reaction, right? Okay, Now one thing important. For example, I am saying this is going from A to B. This is growth of the bacteria. Initially you had A0 and this was 0. Now X amount has been decayed or added. If I want to write growth of bacteria, because growth of bacteria is the only case where reactants are increasing. Right? Where reactants are increasing. The reactants are not decreasing in growth of bacteria. The reactants are increasing in growth of bacteria. Right? Okay. Yes. Now, here you have A0. Right? Here you have A0. Yes. This is A0 to 0. Yes, but that is not there in NEET syllabus. Right? So, this is A0 to 0. This is A0 minus. Right? Minus or plus, because there is growth of bacteria, so that is plus X. Right? Because you are adding something. There is addition of something. The bacteria is growing. If the bacteria is decaying, then I will write A0 minus X. But if the bacteria is growing, it will be A0 plus X. Right? And this will become your AT. That is your final thing. Right? Okay. Okay, X is the number of moles associated. Here we have basically the number of moles decayed or added. Here these are the number of moles that we add in our growth of bacteria. That is why here also you will have B0 amount of this will be there. No, B0 amount will not be there. Right. So instead of this you will have A0 and this is your A0 plus X. So if you want to apply the formula, that will be K is equals to 2.303 by T, 2.303 log base 10. What is the initial? Initial is A0. What is final? Final is A0 plus X. Right? Why I have written the case specially? Because it's the only case when the bacteria's reactants are increasing. Okay? So don't write there saying that this much bacteria has been grown. Right? Then you have to add that thing. Okay? Then you have to add that thing. Now we will understand how to use the formulas here, how we use the formulas. For example, the formula we know that the formula is K is equals to 2.303 by T log base 10. This is initial concentration by final concentration. Two ways they ask you the question. One is in the form of percentage, one is in the form of fraction. Right? If for example they are saying in the form of percentage, they are saying X is consumed. Or you can say X percentage is consumed. Or Y percentage is left. What will be the answer? If you talk about X is consumed, then you will write K is equals to 2.303 divided by T log base 10. X percentage is consumed. Initially it was A0. Now X percentage, and I will take the A0 in percentage as 100. Initially, because nothing will be given to you. This I am talking when no initial concentration is given to you. So how you are going to take that? Right? So for example, it is in the percentage. They have given you 40% is consumed, 30% is consumed. So you will say initially you will take it as 100 and then in final you will subtract X percentage here. That will be your answer. Right? That will be your answer. Or you can also write it as, or if you want to write Y percentage is left, you can write it as 2.303 divided by T log base 10. Initially it is 100. Now Y percentage you are left with. That means that is your final percentage. Right? So that is, you will say here it is Y percent. 100 by Y. Okay, that will become your answer. Right? Now if they are saying that X fraction, if they are saying in fraction, X is consumed. This is in fraction, not in percentage. Or Y is left. Then what you will do? Simply you will say K is equals to 2.303 log base 10. Because it is in fraction, we will not say initial is 100. We will say initial is 1. So 1 minus, because X is consumed, it will be 1 minus X. For example, they are saying 2 by third is consumed. So it will be 1 by 2 by 3. This will be your final concentration, right? If you're saying that this much is left, so it will be 2.303 log base 10. This is 1. How much amount is left? Y amount. So it will be Y, right? It will be Y amount will be left behind. Right, students? Y amount will be left behind. Now tell me, is that clear to everybody or not? Is this thing clear to everybody or not? Right? How you are going to do the questions. This is for your numerical portion. This is for your numerical portion. This is how you are going to solve the numericals when no initial concentration is given to you. Either it is given in percentage or it is given in fraction. For percentage, it is initial is 100, 100. For fraction, initial is 1 and 1. Right? Okay. Chalo. Now, let us see. They are saying typical first order reaction. Now, they are saying for gases. So, let us write down for gases here. Right? I am writing it down for gases. Right? I am writing it down for gases. What you will do? Wait a minute. For gases, let us see what we will do. For gases, simply, you can say that, for example, A is forming 2B. Initially you had A is forming 2B. Initially you had pressure is equals to P naught and this was 0. But finally you have P naught minus X amount of pressure is decreased. Right? And here what amount will be formed? 2X amount will be formed. That is the pressure. Right? Okay. Now, one thing will be given to you in the question. In question they will give you PV, that is pressure of the vessel. Pressure of vessel they will give you. Right? So when pressure of vessel they will give you, what you will see? That the pressure of vessel is equals to the full pressure here after they have been reacted. So full pressure here is P naught minus X plus 2X. So it will become P naught plus X and this is PV. So X will become PV minus P naught. Now initial pressure will be given to you in the question. This will be given in the question. This will also be given in the question. What is they will say this is the initial pressure, the pressure of the vessel is this. From there you can calculate. Now this is not a formula. Again I am saying this is not a formula. I have taken up this reaction, that is why the formula has come out to be this one. Right? If there is some other reaction, formula will be different. But what you have to do, you have to, for example, they are saying here this is 2A give rise to 3B. Then you will say P naught and this is 0. This is P naught minus 2X. This is 3X. Then this will become your full PV. Right? Then this will become your full PV. That is why in equilibrium I told you, this you will use in so many cases. Right? Okay. So now tell me, if you want to apply the first order reaction, what you will do? That will be K is equals to 2.303 by T log base 10. Initial pressure is P naught. Final pressure is P naught minus X. X you can calculate from here. Initial pressure you already know. From that you can calculate the value of K over here. Right? From that you can calculate the value of K over here. Yes, students, from that you can calculate the value of K. This is only for gases. For gases. Right? Okay? This X you have to calculate like this. First you have to write the equation. Then write it down the same way that you have written in ionic equilibrium. Right? Then this total pressure is going to be the pressure of the vessel that will be given to you in the question. Right? Okay? Chalo. Now let us do some questions, right, based on this. First is NEET 2020 question. The rate constant for a first order reaction is this. The time required to reduce 2 gram of the reactant. Right? Very good, very good, very good. Now the rate constant for first order reaction. Achha, before that I have one thing for you. Chalo, tell me, I think let's take break now, because after that, no, we will start the numericals, because there is one more portion that we are left with. I'll tell you that one more portion, and numericals we will do after the break only. Right? So one more portion is that like in your zero order reaction, we know that T 50%, right? Or you can say T 100%. T 100% was equals to 2 into T half, isn't it? But in first order reaction, this is not the case. In first order reaction, what is the case? The case is, for example, you have 100 molar. Now, the concentration will become 50 molar. That means you have used T half here. Now, after this, the concentration will not become 0 because the rate is dependent on the initial concentration. Rate is dependent on the concentration. That is the reason it is not independent that it will again go 0 molar. No. Now in first order reaction, again when you apply T half here, you will see I need, for example, T half is 5 minutes. After 5 minutes, you will have 50% of the concentration will be reduced. Now if you give it more more 5 minutes, for example, T half is 5 minutes. Now if you give 5 minutes, it will be 50 molar. After 10 minutes, it will not be 0 concentration. Rather, it will be half of this, that is 25. That is 25 molar. If you again give it T half, again you are giving it T half, again you are giving it T half, that is again you are giving it 5 more minutes, that is 15 minutes. You'll see now maybe concentration has reduced. No, even now it is half of this concentration, that is 12.25. Now if you say, ma'am, maybe after this the concentration will reduce to 0, but now after giving it more 5 minutes, I am just assuming that T half is 5 minutes, okay? Now again it is half of this, that is 6.25, half is 125, right? 6.125, is it? Wait a minute, this is 6.5, this is 12.5 and this is 6.25, right? Now, again I am saying I will give it half. Again I am saying I am going to give it T half. Again I am saying I am going to give it T half. More 5 minutes I am giving. More 5 minutes I am giving. Now tell me what will happen. Now tell me what will happen. Again I am giving it more T half. Now also the concentration has not reduced. Rather it is half of this. So it will be 3.125. Now again I am giving it T half. Again I am giving it T half. Again I am giving it T half. Then take 5 minutes more. Now tell us what is the answer. Now again it is half of this and the half of this will be something 1.5625, right? And again it will be, we will give it T half, again it will be half of this. And doing this again and again and again and again, at one point you will have few things here, that is your T 99% is equals to 10 of T half. After 10 T half, for example, your time is 5 minutes. So 5 into 10, that is 50 minutes. After 50 minutes, your 99%, right? Your 99% of it will be consumed, right? Okay. Okay, students. Now, this is the thing that you need to remember. Now, what about the other things? Now, what about the other things? This you can understand from this table itself. If I want to consume how much percentage? If I want only 12.5% to left behind, right? Then I will need 3 T halves. If I want only 6.25% to left behind, then I will need 4 T halves. If I need 3.125 to left behind, then I will need 1, 2, 3, 4, 5 T halves, right? So from this, the general formulas I am writing here, right? The general formulas I am writing here, wait a minute. The general formulas, let us see that. This will be 50% is consumed. Now let me write down how much percentage is consumed. Here 50% is consumed. Here how much amount is consumed? I'm just writing here 50% is consumed. What about this one? Here, how much amount is consumed? 50 plus 75, right? 75% is consumed. What about this one? What about this one? Here, 75 plus 12.5, that is 567. 87.5% is consumed. 87.5% is consumed. Here, how much amount is consumed if you talk about from this to this side? From this to this side, how much amount is consumed? Right, this is the best way to understand this thing. How much amount is consumed here? This is your initial 100%. Now you are at 6.25. Right, how much amount is consumed? You can just subtract 100 minus 6.25. Right, or you can add here 6.25, that will be 87.5 plus 6.25, that is 5, 6, 7, 12, 13, 93.75. But usually they will ask you till 87.5 only, or maybe 75, right? And here how much amount is consumed? 50%, right? So I'm going to write it here. T of 75%, T of 75% is 2 into T half, right? T of 75% is 2 into T half. T of 87.5%, T of 87.5% is, how much T halves you need? 1, 2, 3. 3 T halves are needed, so it is 3 into T half. T of 93.75. T of 93.75 is equals to 4 into T half. Right? Okay? Okay, students? Understood this or not? Yes, everybody? I hope so that I don't want you to cram this. If you want to cram this, you can. But otherwise, you can use just this thing and you can use your formula. Right? Okay? Okay, everybody? Yes. Now, we will take break, right? We will take break, and after the break, we will complete the rest of the chapter, right? Most of the things we have done. Now we are left with some of the important things on calculating, how to calculate order of the reaction. Then maybe some of the, some of the hints will be given to you in the question, right? Okay? Yes. So I'll give you 10 minutes break and I'll see you after that. Yes? Okay. Okay, so yes everyone, am I audible, am I visible? Okay, so just give me a minute, yes. So where we were at first order reaction, right? So we were doing the questions here, let us do the questions here, okay? Now, let us speed up. This was the question. Now let us start the questions here, right? NEET 2020, you will get an idea what kind of questions they can ask you, right? Okay, what kind of question, and question practice is very, very important. You can get an idea here, right? So the rate constant for first order reaction is given to be this. Rate constant for first order reaction K is given. The time required to reduce 2 gram of the reductant to point this. This is your initial and this is your final weight, right? Now they are asking the rate constant for the first order reaction is given to you. They are asking you the time. So you just need to apply this value here. That is going to be K is equals to rate constant they have given you. They are asking the time 2.303 divided by K natural log of 10. This is your initial. I know here they have given you in the term of weight, not in the form of concentration, right? This is final weight, this is your initial weight and this is your final weight, right? So you can write it in terms of weight as well. So that will be W0 by WT. You can put the values here. It will be 2.303. What is T? T we have to calculate. What is K? 4.606 into 10 raised to power minus 3 log base 10. What is W naught? W naught is your initial 2 and final is 0.2. Solve this and you will get your answer in seconds, right? Okay, you will get your answer in seconds, right? Okay, yes everybody. So answer you can easily get, it is coming out to be 500 seconds. Just put the value, this value, this value, this value, this value. The answer will be 500 seconds, right? Now, next is your rate constant for a first order reaction is. They are saying the rate constant for the first order reaction K, the time T, 2019 question, right? The rate constant K they are asking you for first order reaction. The time required for the completion of 99% of the reaction is given by. Okay, good. So what is T 99%? That is equals to 10 into T half, right? And what is the value of T half? Everybody, what is the value of T half? That is 0.693 divided by K, right? So T 99% is going to be 10 into this, so it is going to be 6.93 divided by K. So answer is going to be 6.9, wait a minute, 6.9 divided by K. So this C is going to be the answer, right? C is going to be the correct answer here. Wait a minute. The rate constant of the first order reaction 99%. Why? Wait a minute. They too have solved it, but we have done the direct formula method, right? Wait a minute. T99, wait a minute. Let me see. Because I want to do the direct only, not through that formula. Wait a minute. Oh. Yes, that was actually T99.9, not T99. So let me correct that thing here, right? It is T99.9. Yes, my mistake, my bad, right? So it is T99.9, right? Not T99, right? So for T99, what we should do? For T99, we can just apply the direct formula. That temperature time they are asking you, that is 2.303 divided by K. This is log base 10. Initial I am taking it as 100%. Final I am saying percent of it is consumed. So 100 minus 90, 99% is consumed, right? So this is 99. So I'll take it as 2.303 divided by K. This is log base 10. This is your 100 divided by 1. You can take it as 10 raised to power 2. So 2 will come to this side. This will be 2.303 multiplied by 2 by K. This is log base 10 of 10. That will come out to 1. So answer is going to be 4.606 divided by K. Answer is going to be D is the correct answer, right? Okay, D is the correct answer. Okay, 2.3 log 10, yes. So D is going to be the correct answer. Please write it, please make this correct. It is 99.9, not 99, okay? Okay, that was my mistake, so please correct this, right? Okay, now next question we have is the first order reaction. Now this is also NEET 2019 question. The first order reaction has a rate constant. This rate constant is given to you. The time required for 40 gram of this reactant to reduce to 10. 40 gram is initial is given. This is the finals which is given. So they are asking you the time. Time is equals to 2.303 by K. What is K? 2.303 into 10 raised to power minus 3 log base 10. Log base 10 initial is 40, final is 10. So it will be 2 raised to power 2. This will cancel out. This will be 10 raised to power 3. And it will be 2 raised to power. So it will be log 2 log 2. What is log 2? Log 2 is 0.301. So this is 0.301. 2 into 0.301. That is 602. 0.602 into 10 raised to power 3. Right? 0.602 into 10 raised to power 3. It will come out to be, because this will go here, 1000 will cancel. This will be 602 seconds. So answer will be D is the correct answer, right? Okay, D is the correct answer. Yes, students, D is the correct answer. Initial, final, put the value, simple, just directly write the formula. And they are asking you question based on first order reaction only. You can see that, right? Now, next is NEET 2017 question, right? That is, a first order reaction has a specific reaction rate of 10 raised to power this. Reaction rate. Now, what is this specific reaction rate? Right? This specific reaction rate is nothing but rate constant. Right? This is a new name for this. NEET 2017 question. This is rate constant that is given to you. First, this is per second. That means they are talking about the first order reaction. Right? Here also they have mentioned it. If they have not mentioned whether it is first order or second order, you can see the units of K and understand whether it is first order or second order. How much time it takes for 20 gram, that is your A0, to reduce to 5 gram, that is 80. Right? So this will be again time they are asking you 2.303 divided by K. What is K? 10 raised to power minus 2 log base 10. Base 10 it is 20, it is 5, 5, 4. Again it will be 2.303 into 10 raised to power 2 into 0.602. Right? So you can solve this and you will get your answer. Right? You can solve this, you will get your answer 2.303 multiplied by 60.2. Right? Because 2 zeros will cancel here. Right? And hence you will have the answer in seconds. Right? Okay. Okay, you will have the answer in seconds. So answer will be 138.6. Just do the calculation, you will get your answer. Right? Okay. Chalo. Next is, what are pseudo reactions? Now, what is pseudo reaction? Which we think that actually it is a second order reaction, but actually it is a first order reaction. The best example is when you are doing the not esterification, when you're doing the opposite of esterification, or you can say you're doing saponification. If you don't want to talk about saponification, you can just say in the hydrolysis of ester, right? When you're doing the hydrolysis of ester, right? Hydrolysis of ester. Now in hydrolysis of ester, this water is in excess. That is why it does not take part in the rate law. Rather, this only take part in the rate law. So the rate is proportional to only this thing, that is your ester, not to water, right? That is why it is a first order reaction. You will think that it is a second order reaction, but in reality, it is a first order reaction, right? It is considered as first order reaction. Reaction in which kinetics is studied by decreased order as shown in pseudo order reaction. It happens when this case, right? Reaction which kinetics of the reaction is studied by decrease, this too we have done, right? Second is rate law equation involves catalyst. Sometimes it involves catalyst. For example, this is the equation of inversion of cane sugar. So it is involving a catalyst, right? But here it is not dependent on that. It is also a first order reaction, right? It is not dependent on this thing, right? Also, it is not dependent on catalyst. For example, what is the work of the catalyst, right? Work of the catalyst, it is just useful in making the products. It will increase or decrease the reaction, right? That's it. That is why when you are saying that rate law equation involves catalyst, in that way also it is considered as first order reaction only. Not always. I am saying when you have a catalyst, in that way we will study it by decreased order. We will in reality, we will think that it is a second order reaction or maybe third order reaction. But in reality, the order will be less than what we have assumed, right? Okay, so they will not ask you the examples. Just remember, hydrolysis of ester is a pseudo reaction, right? Where the rate is actually first order reaction, right? Now we will see that how you can calculate the order of the reaction by hints. Hints will be given to you. This is also asked, right? Hints will be given to you. You have to calculate the order of the reaction. I will give you simple direct methods for that. First is, for example, some practical thing is given to you. Some experimental thing is given to you. So, I am writing it here. I am writing my own question here, right? So, I am writing the question here. The question says that, or I should just wait a minute. I'll write some different terms here so that we are able to understand that, right? Okay. By trick, because I'm telling you. See, what kind of question you will see in the exam. Now, for example, A is 2 into 10 raised to power minus 3. Here A is 2 into 10 raised to power minus 3, but here A is 8 into 10 raised to power minus 3, right? And here it is 5 into 10 raised to power minus 2. Here it is 10 into 10 raised to power minus 2. Here it is 5 into 10 raised to power minus 2, right? Here the rate is, I'm just taking a random example, rate is 4, right? 4.2. So let us take it 4 only. And here the rate is 8. But here the rate is 60, right? Okay. So you need to tell me what is the rate law equation of this thing, right? Okay. You need to tell me what is the rate law equation of this thing. So randomly I have given you some examples, right? So now here firstly I will compare between 1 and 2. Firstly I will compare between 1 and 2, right? I will compare between 1 and 2. Now here A is constant. I will take it as rate. Rate is directly proportional to. Now I will see how it is with respect to B, what is the order. With respect to B, how I can see, if this is multiplied by 2, this is also multiplied by 2. For this, you need to remember one thing, that your new rate is equals to x raised to power n of old rate, where x is the increase in concentration and your n is order of reaction. N is order of reaction, right? If I apply the same thing here, okay, this is the formula, right? A trick that I have made for you, right? Now, because students find it difficult, so I have made a simple trick for you, right? So now I am telling that if B is doubled, then your rate is also doubled. Rate is also doubled. So if you put the same thing here, new rate is equals to 2 times old rate. This is what I am telling you. That means the order must be 1, only then this is possible. Tell me one thing. I am saying that new rate is double of old rate. Order is doubled. That means the order must be 1, only then it is possible. If n is 1, only then it is possible that it is doubled. Right? So here, can I write here that it is with respect to B, it is first order reaction. Now I will write about the change of first and third, right? So here it is constant, so I'll write it with respect to A. When A is 3 times, this is increasing 3 times. It is increasing 4 times. It is increasing 4 times. So when that is possible? How that is possible? It is increasing 4 times. I think 4 times will not make anything, but chalo, let us try. If I am saying that rate is increasing 4 times, right? But your A is only increasing 3 times. That means here A is 3. Here A is 3 and this is your rate of old. I think instead of this, we should write here. We should write 9 here, right? Because this is the question I have made, right? So in the example, they will give you proper question, right? Which will have an answer, right? So here I am saying that this is jump to 9. Okay? Yes. Now tell me, will this be a first order, second order, which order reaction? I am saying concentration, that means X has increased 3 times. I have put 3 on X. But the rate has increased how many times? How many times it has increased? Wait a minute, yaar. It's so very difficult. Wait a minute. If I want to make it like it 12. Wait a minute. I am writing 12 only. Hana? Yeah. So let us write 12 only. So with 12, what will happen? With 12, it will increase by which thing? Rate is increasing by which thing if I am writing 12 here? Rate is increasing by which thing if I am writing 12 here? Rate is increasing by, wait a minute, 3 times. This to yaar, it will be the same thing. I want to have some different kind of question. Wait a minute. Let me increase the rate to 32. Chalo. Now tell me what will be the increment, how much it is increased. Now tell me, I think this is a better question, right? Because let's complicate the question little bit. Now only then there is some use, right? So now it has increased to 34. Hanji, everybody, how much time it has increased? How much time it has increased, students? How much time it has increased? Yes, 8 times. Very good. Right? Now you tell me, if it has increased 8 times, I am saying the rate has increased 8 times. Right? How that is possible? If I want to say the rate has increased, basically this should be 8 times. This should be 8 times. This is only possible. Now my order will be in fraction only. So let us write it in fraction only. How this is possible that my order to be in fraction? Now I will just compare these two things. So it is 3 raised to power n is equals to 8, right? Again, it is not, yaar. Oof. Can you give me any idea? Oh my god, my brain is not braining, guys. My brain is literally not braining. Okay, I'm so sick and tired of this thing now. Okay, just give me a minute. I'll do some calculations here. If I want to have. Wait a minute. Now we will have the correct answer. Yeah. Now also we are not able to have the correct. Okay, just give me one time. I'll just pick out some questions from the book itself. Otherwise, I'll just get confused only. Right? Okay. So just give me a minute. I'll pick out some question from here only. 2 into 10 raised to power. I'm just writing it here. 2 into 10 raised to power minus 4. 2 into 10 raised to power minus 4, and this is your 16 into 10 raised to power minus 3, minus 4. Now I think we can calculate it. Now it will be better. At least we will get some answer here. Right? Chalo, let us see. I don't know, I was trying to make the question myself, but I am not able because, you know, otherwise the answer will be very tough. Now let us see if, again, this is not a bookish question. Again, I have these terms, so I have written it myself only. Let us see what happens here. Let us see what happens here. I don't know what we are doing right now. So see, this is your, you will take A as, first you will take A as constant. Okay. So I'll do one thing. I'll just erase everything here. Okay. I'll erase everything here. I'm making my own table here. Right. Okay. I'm making my own table here, right? Wait a minute. This is A, this is B, and this is your rate, right? This is your rate. So now let us write this is A, this is B, and this is your rate. So I'm writing here that this is 0.1, 0.1, and this is your 0.1 and 0.2. And this is 0.2 and 0.1, and this is 2 into 10 raised to power minus 3, 2 into 10 raised to power minus 3, 16 into 10 raised to power minus 3, right? Now because this is a question from book itself, now we will have no problem, right? We can easily apply that trick here, right? Now let us see, I told you one thing, that your new rate is going to be x raised to power n times of old rate. Right? So, if I want to have A constant, now if I say my A is constant, but my B is multiplied by 2, in that my rate is constant, right? If I am saying my new rate is equals to old rate, right? But my concentration is getting multiplied by 2. Now, how that is possible? That is only possible in case of zero order reaction. If it is a zero order reaction, only then, even if the concentration is getting multiplied, I will have it as equals to old rate, right? So with respect to A, you can say that with respect to A, it is a, not with respect to A, with respect to B, it is a zero order reaction because B is getting doubled, but there is no change in rate, right? If you want to write for A, here A is getting doubled, but the rate is also getting how many times? 8 times, right? Rate is getting 8 times. So now your new rate is equals to how much times? 8 times of old rate. But the concentration has increased to how much times? 2. So it is 2 raised to power n. How come 2 raised to power n and 8 are equal? When it is a third order reaction. For n is equals to 3, 2 raised to power 3 is equals to 8, right? That means with respect to A, it is a third order reaction. Okay, with respect to A, it is a third order reaction, right? So basically, these are the things. So very simple trick I have made for you, right? That what you need to see, because otherwise, you know, you will start doing this and that, you will solve everything, rate constant, everything, then you will get your answer. Here, you just need to remember this thing. You will put the value that how much concentration it is increasing, that will be X. How much order, that will be N, right? So, you will see the rate. For example, here the new rate was equals to old rate, right? But in reality, concentration was getting double. So, 2 raised to power N should be equals to 1. 2 2 raised to power n should be equals to 1. That is only possible if n is equals to 0, right? So the overall rate will become a raised to power 3, b raised to power 0, and that is, this will become your final answer. Okay, this will become your final answer. Okay, now that was the dependency of rate on this thing. Now, otherwise what you would have done, you would have done this thing. You would have calculated this for different with respect to A and B. 3 formulas you have to put, then apply this, then divide this. On the second page also it is going. Then you will have your answer. But I have given you a simple trick based on that, right? Next is graphs we are already done. Next is your half-life. Now for half-life we have a direct formula. How this formula is generated? From the trick that I have given you. That is, T half is directly proportional to A naught 1 minus n. A naught 1 minus n. Right? So you take 2 T halves, T1 and T2. Right? T1 is directly proportional to 1 by A1 n minus 1. Or T2 is directly, or you can say A1 1 minus n, or this is A2 1 minus n. You divide these two things, you will get T1 by T2, both are half-lives. T1 by T2 is equals to A2 by A1 n minus 1. Then you take the log of this. If you take the log of this, it will be log of T1 by T2 is equals to n minus 1 log of A2 by A1. From here, you can get this equation of n. Now, for example, half-life corresponding to two initial concentrations are given to you, right? So A1 and A2 are initial concentration, and T1 and T2 are half-life, right? So initial concentration, if for two sets half-life and initial concentration are given to you, this is how you will solve the order of that, right? Okay, this is how you will solve the order of that thing, right? Now, it's a very, very important question. Let us see that question. That is, rate of decomposition of ammonia is found to be dependent on concentration. How? So now we can see that this is the rate, right? Decomposition of ammonia, the order of the reaction when concentration of this. Now, D of NH3 divided by dt will be equals to, if I divide it by NH3, because they are giving me concentration is very high, is very low. So I need NH3 in the denominator. So that is why I will divide this by NH3. So it will become K1 by NH3 divided by, right, K1 by NH3 divided by 1 by NH3. Here also I will divide. Here it will be K2. Now I will apply the same thing here. Now if I am saying NH3 is very high, concentration of NH3 is very high. That means 1 by NH3 is going to be very low. If 1 by NH3 is going to be very low, we can neglect this thing. Right? We can neglect this thing. This thing means we can neglect this thing, right? We can neglect this thing because this is 1 by NH3, right? Because this is 1 by NH3. If you want more clarity on this, this is division. We can neglect this thing. We can neglect this thing. So answer will be K1 by K2, which is independent of the concentration. When the rate is independent of the concentration, for zero order reaction. So this is going to be a zero order reaction. If you talk about concentration of ammonia is very low. If ammonia is very low, that means 1 by NH3 is going to be very high. If 1 by NH3 is going to be very high, so can I write it here? This is K1 by 1 by NH3 divided by 1 by NH3 plus K2. If this is very high, so in comparison to this, K2 we can ignore. We should ignore K2. So answer will be K1 divided by NH3. Wait a minute. Acha, this was, wait a minute. Wait a minute. This was divided by NH3, so it should become K1 by 1 plus K2, right? This should be NH3, right? And here, first option was, if your NH3 is very high, if NH3 is very high, 1 by NH3 will be very low. If this is very low, we can neglect this thing and it will become K1 by K2, independent, that will be a zero order reaction. But if you talk about if NH3 is very low, right? So 1 by NH3 will be very high. In this way, we can write K1 by 1 by NH3 plus K2. Now, if this is very high, so for example, you have 2000 rupees. In front of that, you can ignore 0.1, right? What is the value of 0.1 in front of 2000? Nothing, no. So, if I am saying this 1 by NH3 is very high, so in comparison to this K2 will be very low. So, this K2 is very low. So, we can see that as K1 by 1 by NH3, that will be NH3. So, that means in the second part, this rate is directly proportional to NH3 raised to power 1. That means it is a first order reaction. That means it will be a first order reaction. Here it will be a zero order reaction. So this is also different question, right? A different question from where you can predict the order of the reaction, right? Okay. Madhumati, I will let you know about it. Okay. Yes. Now, next is effect of temperature, right? Effect of temperature, I'll directly tell you what is the effect of temperature here, right? Wait a minute. Effect of temperature, just remember one thing. A trick again, I am writing here one trick. Very simple, very easy trick I am writing here, right? So, very simple trick is, the way they ask you the question, find the value of M. M means final temperature minus initial temperature, nu minus old, divided by 10, right? And then your rate of nu rate will be 2 raised to power M times old rate. That's it. Why I have written this example, why I have written this here? Because after every 10 degree rise in temperature, the rate is doubled. After every, here you can see, generally it has been found out that every 10 degree rise in temperature, the rate constant is nearly doubled, right? The rate constant will be doubled here. So here, for example, they are asking you that you have increased the temperature from 40 degree to 100 degrees Celsius, right? Okay. Now, find the new rate constant. What will be the new rate constant? New rate constant will be equal to, first you should find the value of M. M is final temperature minus initial temperature divided by 10. That means 60 divided by 10, that is 6. Now, your new rate constant is equals to 2 raised to power old, 2 raised to power n of that, 2 raised to power m of that old, right? This is the old one, right? So, it will be 2 raised to power 6 of old, right? So, that will be your answer, right? Okay. Understood? So, that is a very, very simple thing. They can ask you any temperature, they will ask you what will be how many times the rate constant will increase. So, you can directly write the rate constant as well, right? Okay. Now, here they are talking about the activation energy. Now, students, understand one thing. Whenever, for example, I am talking about NEET exam. NEET exam also has some cutoff. From that cutoff only, if you are above that cutoff only, then you can think about your rank. If you are below that cutoff, then it's not possible, right? Then it's not possible. Now, the same way, if any reactant wants to get converted to product, it will have that cutoff, and that cutoff is called the activation energy. It should have that much amount of energy so that it can jump that barrier, right? So that it can jump that barrier. So now it is very simple that this is your reactant, it is getting converted to product, right? And it should have that energy of activation, and here it will have that activated complex, then only it will decrease the energy and will get converted to the product, because more the energy, less is the stability, and activation energy is maximum in this. That is why least stable, that is why transition states, intermediates, they are not stable, because they are the activated complexes, right? Now, second thing here is whether it is endothermic or exothermic. As you can see, this is your delta H for, this is your enthalpy of reactants, this is your enthalpy of products. So what is delta H is equals to enthalpy of products minus enthalpy of reactants. Product is less. We know that enthalpy of product is less than enthalpy of reactants. So this will be a negative thing. So that is why this reaction is a exothermic reaction, right? They can ask you, they can give you one diagram, they can ask you whether this is exothermic or endothermic. From this thing, you can answer that, right? Now, next is very, very important, very, very important. In this case, we are going to see on increasing the temperature exactly what is happening. Now, very important thing, I'll tell you this with the help of one very beautiful story. So, the story is that what happened, this is your kinetic energy, these are the marks, these are the marks of students, and these are the students. These are the number of students. These are the number of students. This is with an example. Now, in a class, if you talk about someone who is scoring 35%, 40%, that kind of students are also very less in a class. And the students who are scoring 99%, 98%, they are also very less in a class, right? The most probable students are the ones who are scoring around 70 to 85%, right? These are the average students, right? So here also, least kinetic energy is also possessed by very less number of molecules. Very high kinetic energy is also possessed by very less number of molecules. But most probable kinetic energy that is possessed by most of the molecules is called the most probable kinetic energy. And here, this is the maximum. And it is not the maximum kinetic energy. There is difference in that. Maximum kinetic energy is this one. This is the most probable that is possessed by a lot of students, right? Okay, that is possessed by a lot of students. For example, in NEET, most of the students, they score between 400 to 500 or maybe 300 to 500. Those who are above 550, right? They are in this category. Those who are below 400, they are in, or 300, they are in this category, right? Okay. What happened? Okay. Now, here this is I think now it is clear that what we are representing here, we are representing the most probable kinetic energy which is possessed by most of them. Now, when we increase the temperature, kinetic energy will increase, right? For example, you have a good teacher. You have a good teacher. So, when you have a good teacher, what will increase? Some of the students who don't want to study only, they will be at the same level only. They don't want to study. Some students who were at the average position, who were scoring around 350, 400, now they have a good teacher, right? So that is why they can score more with the hard work, right? So now, earlier, this was the most probable, right? Earlier you can see that when there was no good teacher, most of the students were scoring around 60%, right? Most of the students, or you can say around 70%, they were scoring average marks. But now they have a good teacher. So those students who just needed a good teacher and concept clarity, they will score around 85, maybe 90%. That means now in that class, because they have good teacher, most of the students, they will shift towards scoring good marks, right? So that is the same thing here. Earlier, they had low temperature. In that case, most probable kinetic energy was less. But now, as the temperature has increased, kinetic energy has increased. That is why the most probable kinetic energy has increased, right? So this is the initial kinetic energy. This is the final kinetic energy, right? So when temperature increases, the maximum of the curve moves to the higher energy value and the curves broadens out. Okay, understood this thing? Yes, yes. Now, last is effect of reaction. Now, this is the This also has been asked in your NEET, right? Okay, this too we have done, right? Now this also has been asked. This formula is very important. Firstly, this formula is very important. That is natural log of K is equals to E minus EA by RT plus ln A. Now what is this ln A? What is this ln A? A is the Arrhenius constant, right? A is the Arrhenius constant. EA is the activation energy, R is gas constant, T is temperature, K is the rate constant. Now for example, you are given two rate constant. This also is a very, very important formula. You are given two rate constants, you are given two temperatures. Activation energy is given. They can ask you rate constant of second. They can ask you final temperature, final rate constant, anything they can ask you. If two things are given, that means you are going to apply this particular formula, right? Okay. Now, effect of catalyst. Now, what is the effect of catalyst? What catalyst is going to do with activation energy? With activation energy, catalyst is going to make it easy for you. I am your catalyst. What I am doing? If you are supposed to study chemical kinetics with your own, like by own, like what you will do? If you are going to do self study, then what you will do? It will take 5-7 hours maybe, right? Then you will make your notes. Then you will make some tricks out of that. That work already I have done, right? Yes, Tamil asked the question, right? That work already I have done. So basically, I am making it easy for you to cross that barrier. So similarly, earlier the activation energy was very high. Now, because of this catalyst, the activation energy will get low, right? They will lower down the activation energy so that it can get easy for you to cross that barrier, right? So basically, a good catalyst decreases the activation energy, right? Now, okay. Lowering the potential energy barrier, that is your activation energy, right? Characteristics of catalyst. It does not change equilibrium constant but only help in attaining equilibrium faster. The catalyst, the forward as well as backward reaction, so that same. It catalyzes both forward and backward reaction. So to same extent, so that equilibrium state remains same. This we have studied in equilibrium as well. A small amount of catalyst can catalyze a large amount of reactants. A catalyst does not alter Gibbs energy, very, very important, right? It catalyzes the spontaneous reaction but does not catalyzes non-spontaneous reaction. Again, a very, very important points. Theory questions can be asked, which of the following is not true for catalyst, right? Then you have collision theory. Now with collision theory, see, we are talking about when the reactants are going to form products. First thing is activation energy. Reactants should have that amount of activation energy to cross the barrier. Only then they can form the products, right? That is the first thing. That is the activation energy. Second thing is collision frequency, that I will represent by Z. They are saying there should be proper collisions between the molecules so that they can react and give us products, right? The number of collision per second per unit volume in the reaction mixture is called the collision frequency. Now, if we add both the things, that is activation energy, that will be E raised to power minus EA by RT, and collision frequency. These two factors we have added. But they are saying there is one more factor which defines the rate. That one more factor is the proper orientation, right? Proper orientation means it's not like two molecules will collide and make products. There should be proper orientation. That is the reason we study mechanism. That is the reason some mechanism occurs, some mechanism do not occur. The reason is there is no proper orientation of molecule, right? So third factor is orientation. Third factor is your orientation. That is your effective collision. And for that we have the third factor, that is, wait a minute, probability or steric factor, right? That will tell us the orientation. So basically rate is dependent on three things. First is it is represented by R is equals to P Z A B E raised to power minus EA by RT. So it is dependent on three things. One is your activation energy, then there is collision frequency, then is proper orientation, right? Effective collision, right? So three things it is dependent on, right? Okay. Now What I mean by proper orientation, now they are saying that if you want to react one alkyl halide, that is methyl bromide with OH, improper orientation means if I want to have SN2 mechanism here, SN2 mechanism they are talking about, right? So this halide is reacting with this, but there is no proper orientation. Why? Because this nucleophile will attack, give the back attack here. Now it cannot react with this Br, right? So it should have a back attack. Back attack means OH should attack from this side. If it is attacking from this side, there will be no proper orientation. If it is attacking from that side, there is proper orientation. Only then the reaction can happen. Otherwise, if it is attacking from this side, then there is no reaction that will occur. That is why no products, and here you have proper orientation and proper products are formed here, right? Okay. Now, the proper orientation of reactant lead to the bond formation, whereas improper orientation, there is no product formation. Now, they are just telling the drawbacks, the criteria of effective collision. If activation energy, proper orientation of molecules together determine the effective collision. There should be activation energy properly, there should be proper collision, right? Drawbacks of collision theory are the theory considers atoms and molecules to be hard spheres, ignores their structural aspects, right? That means this theory is considering the atom as this thing. It is considering atom as this thing. It is not considering the actual structure of the atom, that there is orbitals, right? It is not a well-defined shape. Atom does not have a well-defined shape. So it is not considering that thing. That is the limitation here, right? That is the limitation. Yes. Oh. So let us see this question that is based on the activation energy formula. For a reaction, the activation energy is given to be 0. Wait a minute, how is that possible? The rate constant is this, the rate constant at 400. Activation energy must have some other value. Wait a minute. It should be, if it is 0, are they taking it as 0 only? They are taking it as 0 only. I thought there is some different value here. Okay, so you'll just apply basically what they are saying. They have given you two rates. K1 is given to you, right? K2 they are asking, right? T1 is given to you. T2 is given to you. EA is going to be 0, right? EA is going to be 0, right? So just apply this formula. Log K2 by K1, that is, then it is EA, and here it will be divided by 2.303, and this is your 1 by, this is 1 by T1 into T2, T2 minus T1 divided by T1 into T2, right? So just put the values, you will get your answer, right? K2 you want to have, so this whole term will be equals to 0 only. Why to put that value? This is 0, this whole term is equals to 0. Now this is log K2 by K1 is equals to 0. Which log is equals to 0? When internally this value, see, log of A is equals to 0 when A is equals to 1. That means log of 1 is equals to 0, right? So that means this K2 by K1 will be equals to 1, right? Okay, so K1 will be equals to K2, that will be the same value. So answer will be B is the correct answer, right? B is the correct answer. Next is 2016 question. The addition of catalyst during a chemical reaction alters which of the following? Addition of catalyst, enthalpy, it has no effect. Entropy, no effect. Internal energy, no effect. It has effect on activation energy, that is your EA. So that will become the correct answer, right? Next question is, again 2020 question, right? An increase in the concentration of reactants. There is an increase in the concentration of reactant of a reaction leads to change in which thing? Which thing? Everybody. Increase in the concentration of reactants. If you are increasing the concentration of the reactant of a reaction leads to change in heat of reaction, threshold energy, activation energy, or collision frequency, right? Or collision frequency. Yes, very good. Here I am not talking about catalyst. I am talking about increase in concentration of reactants. More are the reactants, more is the molecules, more is the collision frequency. Right? So answer will be more are the collision, more is the collision frequency. So collision frequency will increase here. Right? So D will become your correct answer. And that's it. Yes, and that's it. Now let us see the offers that are there for you on Diwali. Let me show you the offers here. Right? Let me show you the offers here. Can you see this? Right? Are you able to see this? Yes. Now, Madhimiti, very nice. Now, let us see the link description box here. Now, first is all these things are in your Diwali offer, right? If you want to see that, ma'am, I want to see DNA batch and Tejas book. I want to buy that thing. So just click on that. You will get to this portal, and to this portal, see view course plans, and here it is given to you. That is for 2999. Your NCERT Tejas book, that is this one. This is your NCERT Tejas book, this one, right? And you will get the DNA batch totally under this only, that is 2999, right? Chemistry, biophysics, everything you will get here, right? I am just holding chemistry book, right? So you will get all the books here, right? And after that, what you do? View course plans, then buy the course, buy full course, put your email ID or phone number, then next thing will be done. Now, if you're thinking that, ma'am, I want to enroll for DNA and year-long test series, I'll say, okay, don't worry about that. Let's enroll into that. View course plans. And here, this is for 2499. NYTS is your year-long test series, right? You click on this, buy full course, and then put down your number or email. Then just, there is no cash on delivery, right? Because some students were misusing it. That is why here we have simple, you have to pay. After that, we will deliver that to your home, right? Now, next is, for example, students want to buy only flashcards, right? You want to buy only flashcards, right? So then what you can do? If you want to buy only flashcards, right? Flashcards, how they look like? This is how the flashcards will look like. This is how the flashcards will look like. It's a very, very beautiful cards. Beautifully, they have written everything in detail, right? In short format, everything is written, right? You pick out anything. This is such a, like, you know, you're totally going to fall in love with this thing, right? All the formulas, everything is mentioned here, right? In a very beautiful way, this is written, right? So I would really advise you at least invest in Tejas book and flashcards. That is my genuine advice to you, right? Genuinely, right? You guys are like my younger brother and sister. That's why I'm advising this to you. Flashcards and Tejas book. If you're like, ma'am, okay, I'm a dropper. I don't want to purchase DNA batch. Ma'am, I want to practice and I want to do revision. Then flashcards and Tejas book is the best thing for you, right? So flashcards, how you do this? So flashcard is for 1243. Right? Again, the price has also decreased. Now 1243, this is your Diwali Dhamaka offer, right? Then you go to this one, right? Hurry up, sale ends in 13 minutes. Now for this 13 minutes, you have it for 1243. I was showing this you for something 1400, right? Now this is for 1243, just 13. What exactly at a right time we have clicked on this. It is just for 13 minutes, right? So now you can just buy it now, right? So click on this and buy it now, because that is just for 13 minutes, right? Okay, so in 13 minutes this will end. That's why I'm telling you. Then you can just put down everything, right? Your contact, your delivery address, everything in detail. You have to put down the address, phone number, shipping. Then save this information for the next time. Payment, you can use UPI, Visa card or RuPay, anything you can use, right? Okay, Paytm you can do, right? And other things also you can do, right? Okay, so that is pay now and that will be done, right? Okay, 1243. Now, if I talk about, I would say just now purchase this flashcards, right? 1200 is like a very genuine price, right? A very genuine. If someone gives me flashcards, this much beautiful things for just 1243, I would not even take 1 minute to think that should I purchase this or not. So do this right now because we are just left with 10 minutes more, right? Now, if you want to purchase, let us say you want to purchase, let us say you want to purchase Tejas books, because this is my favorite two things, that is Tejas books and flashcards, my favorite, right? So here, just click on this, you will get biochemistry and physics, like I have this chemistry book along with me, right? If you have solved this book, nothing else you need, right? You just need revision and your practice book, right? So just go to this Diwali Dhamaka offer. Now, best price, this is activated, that is for 1600, right? 1600 is the best price, right? So you can just buy it now and it will be available to you, right? Okay. So that will be available to you. Just put the information. I think that if you want to purchase DNA batch along with that, so DNA along with Tejas books is also applied here, right? DNA along with Tejas books is 2999. So it totally depends what you want to have, right? If you want to have DNA plus NYTS plus Tattva books, then also you can have this batch, right? You can have this combo where it is for 5499, right? So it is totally your choice. If you want to get enrolled to DNA, instead of doing that after some time, do it now only. I would say your main priority should be Tejas books and flashcards. Then according to you, right? Because Tejas books and flashcards is for everyone. Now it depends on your preparation, that if you feel that you want detailed lectures in your DNA batch, you want detailed lectures, because for chemical kinetics, I will take 6-7 days, right, to complete that, right, in the batch, right? So if you want to do the detail of everything, right, along with DPPs, along with mock tests you want to have, right? So that depends on what is your level of preparation, right? How much you want to practice, right? So according to that, you can purchase any combo that you want to have. Okay, I think that's it. Okay, how many of you are thinking about flashcards and Tejas books? So now only today itself, talk to your parents, right? Tell them that what we are getting in Tejas, what we are getting in flashcards. If you want to see 1 or 2 pages of flashcards, I'll send you that on my Telegram channel, that is Diksha Kaushal, Diksha Kaushal Chemistry Official, right? Even on your NEET English, I'll send you 1 page of that, right? So that what you can get, you can see that, right? What exactly you are getting from that, right? What you're getting from flashcards. So once you have your flashcards, everything will be easy for you. Revision will be very easy for you. Within 5 minutes, you can do the revision. And after revision, you can solve the questions from your Tejas book. Okay? Okay, guys? Yes. Chalo. Okay then, bacha. Bye-bye. Take care. See you all in the next class. And at 2 p.m. I have my DNA batch class also. Right? So yes, for DNA batch students, I will see you in DNA batch. And I think that DNA batch students must be in the DNA batch, because other classes are also going on there. Right? So okay, bye-bye. Take care. See you all in the next class. Till then, Jai Hind.